Mm. Mm.
Hello.
Yeah. Now start, Vinay. I'm going to start. Okay, thank you. Yeah, good afternoon, everyone. Yesterday was one of our faculty, Gnaneshwari. She's covered a basic concept of probability and addition theorem. Up to that, she covered in the last class, means yesterday class. I'm going to take the next part for multiplication theorem. You already know that while solving a problem in probability, there are two rules or two theorems we have. One is addition theorem, another one is multiplication theorem. Okay. Addition theorem and multiplication theorem. Yeah, addition theorem is covered in the yesterday class, Gnaneshwari ma'am. Now I'm going to take multiplication theorem. Keep in mind while solving a problem in basic probability problem, you must be use either addition theorem, multiplication theorem. Sometimes we are going to use both addition and multiplication theorem. Addition theorem is depends upon mutually exclusive. Another word of mutually exclusive is nothing but disjoint. We are in the set theory, are using the word disjoint. Now, in the probability, we are using another word mutually exclusive. Now, like that, whenever I do solve the problem using addition theorem, first I have to verify whether the given events are mutually exclusive or not. Like that, whenever I have to solve the problem using multiplication theorem, first I have to verify whether the given events are independent or not. Don't confuse with mutually exclusive and independent events. Independent events is different and mutually exclusive is different. Just I'll give one simple example. That's a live example. It's not there in any textbook. Now, for example, I'm going to give one problem to solve two students. Both the students are sitting in far from the place. They're not sitting is very close. And also they don't have any mobile or textbook, anything. I'll give the problem to both the students. Both the students have solved the problem. Then both the students are solved independently. You see, both the students are solved independently. Even though solved independently, they sit very far from the place. I feel both are not copied, both are not discussed, both are chatting through any WhatsApp or any message. Now, then I feel both are solved independently. Then even though they solved independently, they have a common. What's a common answer? Suppose both are solved correctly, the answer must be the common, at least one must be common. What's a common is answer. They maybe have more than one common. Maybe both are using same step, same method, but at least one must be common. Keep in mind, whenever the events are independent, then they may be happen at a time. See, both and they are happening simultaneously, they may be having a common. That is a definition of independent compared to mutually exclusive. Now, this multiplication theorem is very much useful whenever we have to take the probability of the events, all are happen, all are must be happen, all are exist. If we want to find out the probability of that type of events, there we are going to use multiplication theorem. Suppose you have three events A, B, C. I want to find the probability of all are happen, all must be happen, A intersection, B intersection, C. Whenever both all are happen means you are giving a connectivity using intersection. At least one must be happen means you are using union. Whenever you are using union between the events, there we are using addition theorem to expand. Similarly, whenever I have to give a connectivity between the events intersection, there we are using to simplify this, to use what actually multiplication theorem. Whenever we are going to apply the multiplication theorem, there we have to know whether the events are independent or not. The events are independent to have a different formula for multiplication theorem. They are dependent, they have a different formula. Therefore, keep in mind why we are go for multiplication theorem, because instead of finding probability of A intersection B intersection C, suppose I had to take product of their probability, then easy to find out the values. But we can't write always. Therefore, there we are observed the two things. One is a independent events, another one is dependent events. Suppose all events are happen. Here I consider two, A and B. See, in your question paper, instead of intersection, they may be take A into B. A into B means understood they have in between that intersection. Then that is also you have to observe carefully. Then the next step is, see, now observe carefully for this part what I'm explaining, intersection independent. See, both independent dependents are taken based on which theorem? Multiplication theorem. In the multiplication theorem, suppose events are independent, then probability of A intersection B can also be written as product of their probabilities. Independent means is all written in my notes. What's the definition? Outcomes of one of event does not affect the outcomes of the other. Then we say that both the events are independent. And next, suppose they dependent. Who is depending upon other? I'll give that is called condition probability. This P probability of P slash A is nothing but conditional probability. Condition means I'll give one simple example. Observe carefully. Now in my class today, I'm taking online probability class. Two students are attending my class. Just imagine. See, one student is already logging, ready to log in around 1:30 because we already announced 1:45. Is login 1:40. Even though he's login, after that immediately he's left the meeting. Why? Because his friend is not logging. A is one student, B is another student. A is logging 1:40, around 1:40, but he observed whether B is logging or not. B still is not logging. What he did is again we quit the meeting. He's left the meeting. Yeah, he's left the meeting. When they maybe put a phone or message like that. Once B is login, then A is login. Means login of A is depending upon login of B. That is called conditional probability. When I'm writing the probability of A attending my today online class is depending upon B. Means while writing probability of A is nothing but probability of A slash B, because A is dependent on B. Whenever B is happened, then A is happening. Such type of probability is nothing but conditional probability. Then same example. Suppose A and B are there. Yeah. Well, A is login in 1:40. Even though B is login or not, is does not worried about that. Now, while writing the probability of attending my online class for both A and B is nothing but probability of A into probability of B, because none of A and B events is not depending upon other. That is independent. Whenever they're having a dependent, there I am writing a probability by using conditional. That's a conditional probability is a very, very important in the base rule also. See, whenever having a restriction, you are not bothered about your friend, you are attending simply directly once so start the class, that is called independent. Whenever talking about independent, they may be having a common. I given this live example is not there in the textbook. Suppose I have to solve two, I'll give two students for one problem. Both the students are solved at a time. Then both are solved independently. They may be having a common. Suppose they solve correctly, at least one common is what actually answer. They may have more than that also. Keep in mind, this is a difference between what about that independent and mutually exclusive and independent events. Most of the students, they're going to confuse. Okay. And then before move to the next step, I want to share with this condition probability that keep in mind this formula is a very, very important probability of, see, just not to told, probability of A intersection B. Suppose happened based on B. B happened, then only is A happening. There, what's the probability from the multiplication theorem? Probability of B into probability of A slash B. Therefore, don't say A divide A slash B. Probability of A slash B from this multiplication formula, probability of A intersection B divided by probability of B. Writing this formula for this, which one is depends based on that I have to write it. Similarly, probability of B slash A is nothing but what actually probability of A intersection B is a common divided by which comes in that which B is having a restriction on A, therefore P of A. This is a way I have to write the probability to find out condition probability. And also you must and should have to remember this based on that they given a problem in the CET. Probability of A slash B plus probability of not happening of A slash B is nothing but 1. You know that probability of happening of the event A plus probability of not happening, the sum of the probability must be equal to 1. Yesterday, Gnaneshwari is already explained this part. Like that, same thing is holds good for conditional probability. Now I'm sharing the another flow chart for that. What's the probability of A intersection B? Suppose B happening based on A happened. Then which one is happened first? A, and then B is happening. Therefore, this is probability of A intersection B is nothing but probability of A into probability of B slash A. See which one is depend, that comes afterwards. Which one is not in depend, that comes first. That's all. This is a thing we have to remember for what about dependent and independent events. Now before moving to the next step, I want to share the multiplication theorem. These theorems are very, very important. If A and B are independents, you know product of their probability. See, instead of finding probability of intersection, this is easy to find out with the help of fundamental formula. And then suppose dependent, which one is dependent? Then we have to use this alternative formula. Okay, these two theorems consider as multiplication theorem. Multiplication theorems are depends upon independent. Addition theorem is dependent upon which one? Mutually exclusive. Okay. The next is, why don't you discuss the problem what they given already in the question paper? Okay. Yeah. The first problem is independent events. See, just I'm giving a name, that's all. In the exam, they're not going to mention. Please go to the problem very carefully. The very first problem is the probability of solving a problem by 3 persons, A, B, and C, independently is given independently, 1 by 2, 1 by 4, and 1 by 3 respectively. Then the probability of problems solved, a problem solved by any two of them. Totally, how many events you are considering here? The solution, I'm going to write it in the right side of the board. They consider A, B, C. What they given in the problem? Probability of solving a problem, they given probability of A is equal to 1 by 2. The probability of B, they solving a problem is 1 by 4. And then probability of solving a event C is nothing but 1 by 3. But they mention A, B, C are independently they solved. All events are solving independently. They are not depending upon anyone. Then the probability of the problem is solved by any two of them. At a time, we are giving one problem to all. Means probability of A intersection, B intersection, C. We are giving at a time one problem to all the students. They solving at a time all, means all must be happen. In between A, B, C, the connectivity what actually intersection. But they asking what's the probability of solving, the problem is solving. Problem is solved by any two of them. Means the required probability is required probability equals. What are the possibility? Two at a time they are solved two. Means one is not solved. What are the possibility? A solved, B solved, but at that time C is not solved. This is one possibility. What's the other two possibility? A and B, C is solved, but B is not solved. The another possibility, A is not solved, B and C are solved. See, they asking find the probability of the problem is solved. Any two. They are not mentioned A B solved, C is not solved, A is solved, C is solved like that. Any out of three, any two are solved. One is not solved. Means they may be happen any one of the events. Either may be happen this, this, this. At least one must be happen. That give rise the solution of probability of the problem is solved by any two of them. At least one must be solved. Why I'm using the word at least? Why? Because this also answer for that. This also answer for that. This they are not mentioned any two of them. At least one. At least one means what's the connectivity you have to give? Union. Yeah, they give a connectivity union. But at least one must be happen. See, observe carefully. Suppose this happen at a time, you can't expecting these two. Suppose second one happen, you can't expecting other two. Means happening of each possibility are mutually exclusive. You can't expecting all three possibility simultaneously. Therefore, from the addition theorem, I told they maybe are using both the theorem based on that also problem. From the addition theorem, what we get actually sum of their probability. Yeah, I have sum of their probability plus probability of A complement intersection B intersection C. This is from addition theorem. Okay, 8 is not what about that standard notation. Okay, next from the what about multiplication theorem, they given ABC. Keep in mind, ABC are independent means the corresponding complement also independent. This point you already studied in the probability for conceptual. In the chapter wise, you already studied. Keep in mind, whenever they given ABC are independent, the corresponding complement also independent. Therefore, all three are independent. Therefore, from the multiplication theorem, this can be written as what actually probability of A into probability of B into probability of C complement. Okay, plus probability of A into probability of B complement, and then probability of C. Product of the probability from the multiplication theorem. Probability of A complement into probability of B into probability of C. This is from multiplication theorem. Yeah, next you know to substitute. I'm not going to substitute the value, do it you know. But you have a probability of A, how to find out the complement. A complement is nothing but 1 minus B of A. B complement, probability of B complement is nothing but 1 minus of P of B. And then probability of C complement is nothing but 1 minus probability of C. Just you have P of A, P of B, P of C, then I have to subtract with 1, then we get corresponding complement probability values. Just substitute, take multiplication and add. Finally, we get answer. I'm going to write the answer step because this is the next step. It's very simple, not necessary to do it on the board. The final answer after the simplification, we get 1 by 4 is the answer. 1 by 4 is the answer. What's the correct answer here? B is the correct answer. Yeah, I think it's clear. In this problem, I use both the multiplication theorem and addition theorem. At least means union, all must means intersection. Whenever having union and intersection, there we are going to use see why we are using multiplication addition theorem. See, suppose you find a probability of this is very tedious, very complicated. If you want to overcome, better I have to go for addition theorem and multiplication theorem. Then very easy to get a solution instead of taking generally. Okay, I think it's clear, everyone. Now I move to the next problem. Okay. Yeah. Yeah. In this second problem is very easy actually. A flashlight has 10 batteries, 10 batteries out of which 4 are dead. If 3 batteries are selected without replacement and tested, then the probability that all 3 are is dead. Means now we are observe carefully here. First, you have to know what is total number of batteries. What is total number of batteries here? Batteries are nothing but 10. What is the dead number of batteries are nothing but 4. 4. What's the probability of whatever the probability of battery to be dead? Battery to be Dead is nothing but I'm not going to write entire thing on the board. After the class, I'm going to share entire with explanation notes in PDF format in the group. Okay, what is that? Favorable number of cases to the dead number of batteries are nothing but 4 divided by total number of batteries are nothing but 10. Based on that, what we are going to do, move to the next step is what actually the probability that 3 batteries are, see, if 3 batteries are selected without replacement, then we are selecting at a time 3 batteries. Then the probability that all 3 are dead means the required probability. Required probability is nothing but what actually we are selecting at a time 3 batteries, but keep in mind totally 10 students are there. We are selecting 1 student, but we are not going to replace to select the second one. When I selected out of 10, how many for second selection? 9. How many for the third selection is 8. We are decreasing one by one because we are not going to replacing before going to select the next item. Okay, next battery. So what's the first probability of first selection is 10C1 divided by, 4C1, number of total number of dead batteries nothing but 4C1. Total number of batteries 10C1 into all are happen at a time because we are selecting at a time how many batteries? 3 batteries. And then we already selected 1, therefore how many are remaining? We are not replacing, therefore 3C1. In total also we are reduced 1. And also now while coming to the third selection, how many dead batteries are expecting? 2C1 and then 8C1. You know the formula NCR. You already know that what is NCR? N factorial by R factor into N minus R factorial. Therefore, what is NC1 formula is nothing but N. Now, based on that, 4 by 10 into 3 by 9 into 2 by 8. You simplify that. Finally, we get the answer 1 by 30. The 1 by 30 is which option? A. Therefore, the correct answer is 1 by 30. 1 by 30 is nothing but what actually? Yes. Let's move to the next problem. Anybody have a doubt? Free to ask the question and free to put a message in the chat box. Okay. Fine. Yeah. Next problem. In this problem, bag contains 17 tickets numbered from 1 to 17. A ticket is drawn at random. Then another ticket is drawn without replacing the first one. The probability that both tickets may show even number. Yeah. Totally in the bag, how many tickets you have? 17. So in the 17 numbers, what are the 1 to 17? They given very clearly. What are the even numbers? Are nothing but 2, 4, 6, 8, 10, 12, 14 and 16. Totally how many? 8. 8 even numbers are expecting from 1 to 7. Then they selecting one after the other without replacement. The probability that both the tickets may be showing even number. They selecting at a time how many? 2. Therefore, the required probability we are selecting first ticket without replacing to selecting second ticket. It's nothing but what is that? What's the selection of the? See, first I have to know that what's the probability of getting even number? What's the problem? Suppose I'm going to take A is getting a even number. Yeah, getting even number. B is getting odd number. Yeah, what's the probability of A is nothing but 8 by 17. Because total number of tickets is 7, exhaustive case. Out of 17, how many numbers are even numbers is 8. Therefore, what's the probability of getting an even number is 8 by 17. This is 8 by 17 for what? First draw. In the first, while selecting a first ticket, that ticket is even. What's the probability? 8 by 17. Or if you want to write 8C1 divided by 17C1. And then while doing a second selection for the ticket, we are not going to replace the first one. For how many tickets are there? But second one also E1. For 7C1 divided by what actually 16C1. You simplify and then you calculate for this. Finally, we get answer 7/34. This is a way to solve the problem. I'm requesting everyone while doing probability problem, please go through very carefully and then you decide which step I to take. This, see, in the CET, you don't have much time. You must be do practice. Then what way you are sending a message with a fraction second without seeing keys in the phone, a mobile phone, like that you have to send it. You like that you have to know the methods, everything. That much you have to do the practice. Okay. Now, why have I taken product? Both are happen. See, observe with why I taken product. I taken actually multiplication theorem. Why I taken? See, first we are selecting one, and then I have to selecting second one. Okay. See, we already select first one. Now, they're keeping aside this. Observe carefully. The selection of the second one is depending upon the first one. We already, because we are not replacing the first one, no, with the while selecting a second one. What number you selected, that reflect to the second selection. But no issue for this, finding a probability. Okay. The next one is two events. This also they given in once in the question paper. Two events A and B will be independent if which one is correct? They're asking. A and B are mutually exclusive. Definitely it's not this. And then probability of A complement intersection B complement is nothing but 1 minus P of A into 1 minus P of P. P of A is equal to P of P. And then sum of the probability equal to 1. I think anyone will guess this one. Which one is correct? Which one is correct? Please. Yeah. Yeah. No, it's wrong. Wrong. See, how can you say, see, I told beginning, I don't know. A and B are independent. Please keep in mind, A and B are independent. The corresponding complement also independent. Either writing this or this, but in your CET question paper, I saw they're writing prime. Prime is nothing but complement. It's not correct. South is given answer is not correct. Now you see, A and B are independent, the corresponding complement also independent. What is our multiplication theorem says? Both A and B are independent. That gives us product of their probabilities P of A into P of B. Now similarly, A and B are independent, the complement also independent. What is probability of A complement intersection B complement is product of their probabilities, means probability of A slash into probability of B slash. To know that, how to find the probability of A complement? What's the probability of A complement? 1 minus P of A. For the alternative form is 1 minus P of A into 1 minus, yeah. Which option is correct? Option B is the correct. No, this is a simple thing. Simply you are going to lose the marks. That's why you are not score very good marks. After that, you don't get it. Your rank maybe goes in 1000 like that. Please take care that A and B are independent means corresponding complements also independent. What's the formula? You just apply formula for this. Probability of A prime into probability of B prime. Probability of A prime into B prime is not there. What's the possibility? Oh, that can also be written as 1 minus P of A into 1 minus P of B. So we have to observe carefully and choose the correct answer. I think Saujanya is clear. How is answer option B is correct? Okay. Now I move to next actually based on the multiplication theorem. I have to find out the condition probability answer. Answer means observe carefully here. Yes, thank you, Saujanya. Now, you don't see, please think and do it. Yeah, please write what are the things I'm telling you. You write it in your notes. A and B are independent, corresponding complement also independent. Okay. If bag If A and B are two events, yeah, I think it's clear for the this part. How to find out condition probability value based on using multiplication theorem. If A and B are two events such that the given probability of A is equal to 1 by 3, probability of B is equal to 1 by 2, and probability of A intersection B is equal to 1 by 6. Then they asking probability of A prime slash of B. Means just 2 minutes before in beginning slide, let's say, and already I observed this probability of A slash B plus probability of A prime slash B is nothing but sum of the probability must be equal to 1. Therefore, probability of A slash B, A prime slash B is nothing but 1 minus probability of A slash B. We already observed this point. You please write these points in the one sheet. Before going to tomorrow having exam, no? That time you please go through these important points. Then easy to solve the problem in the examination. Instead of solving all the problems in the one day before, you please make a note for the important points. You glance only important points before one day. Then easy to write the answer comfortably within the time constraint. Now, probability of A slash B is nothing but 1 minus probability of A slash B. You know that what's the probability of A slash B from the multiplication theorem. A probability of A intersection B divided by B comes in the after B happened, then only A happening. B happened, then only A happening. For which one comes in the denominator? Probability of B. Similarly, probability of B slash A means probability of A intersection B divided by A happened, then only B happening means A of B. Don't confuse this because they're given in the confusion way the value. They're given P of A and P of B. Even though I don't want P of A, they're given. Don't confuse. Okay. Then 1 minus 1 by 6 divided by probability of what about the B is 1 by 2. Substitute and simplify that. If you know how to simplify, we get 1 minus 1 by 3. Simplify, we get 2 by 3. 2 by 3 is the answer. Means which option is correct? Option A is the correct answer. Now observe carefully. This is the way I have to do it. Okay, somebody they give an answer. Something only very good, ma. Okay, fine. Now move to the next problem. Okay. Yeah. The next problem is actually if these are the question paper problem only. This is one of very simple. I'm not going to discuss. This is very easy. I'll give a hint to do it. If A and B are two events of a sample space, yes, such that once you talk in sample space is denoted by capital S, such that probability of A is 0.2, probability of B is 0.6, and probability of A slash B is equal to 0.5. Then probability of A slash B is very easy. Probability of A slash B, A prime slash B is nothing but what? 1 minus probability of A slash B is already given A slash B. What's the answer? Then easy. The answer is what actually 1 by 2. It's very simple. Yeah, 1 by 2 is the answer. I'll move to the next one. Not necessary to explain much for this. Next problem. Yeah, if probability of A intersection B, they given 7 by 10, and probability of B is 17 by 20, where P stands for probability. They given, not necessary to give what is P stands for, they given in the question paper. Probability, then probability of A slash B is equal to. Yeah, this is what I done in the first two problems. Tell me anyone answer. Anyone, what's the probability of A slash B? Is nothing but probability of A intersection B divided by what actually B happened, then only A is happening. Yeah. Tell me now. Yeah. Yeah. One student given sweet is given answer, correct answer. What's the answer is 14 by 17. I think we get idea how to proceed, how to find out the condition probability value, either maybe complement of the condition probability without complement of the condition probability. I think everyone is perfect about that, how to proceed. Okay, very good. Okay, yeah. Shravani, Priya is also given answer correct, ma. Very good, very nice. Keep it up. Do the same thing in the exam also. Okay. Next, move to the next multiplication theorem. Based on that only. Yeah. If A and B are, this is also one of the question paper problem. What are the problem I'm discussing now? These are the things they given in the question paper only. A and B are two events such that P of A is not equal to 0, means probability of A is not equal to 0. And they given comma, probability of P of A is not equal to 0. P of P slash A, if A is a subset of B, second one, A intersection B is equal to MD respectively. For what are the values of A, probability of A and A intersection B, then what is our probability of B slash A? Please try to understand. They given what probability of A is not equal to 0. And also they asking to, they given A intersection. There are two conditions, two things they given. And we are two events such that P of A is not equal to 0. And P of B slash of A, if A is a subset of B, and A intersection B is what actually? A intersection B is a empty is respectively. Given one student is an answer. What's the answer they given? B is the who is Dina GK. I don't know if she is given answer for this question or previous one. I don't know this. Yeah, one. Yeah, they given one given answer is correct. Actually, both are giving. Sweetie and Nina, they given majority. Southernia, they given be correct. The answer is correct. What you given answer is correct because they asking to probability B slash A. Just now we discussed the formula is probability of A intersection B divided by probability of A. They given very clearly. This is a, please try to understand, this is a value for first condition. This is a value for the second condition. Okay. That's why based on that, keep in mind, the first option, first value is nothing but for A. Second, A and comma B means this is the answer for Roman number 1. This is the answer for Roman number B. They given very clearly P of A is not equal to 0. Suppose P of A is 0, we get infinity. Therefore, what is that? One A. First option is A. A is a subset of B, means 1, comma 0. Is it clear? See, 0, comma 1 is not satisfied because denominator 0 because they given already A is not equal to 0. Both are 1 is not, therefore both are not 0. Therefore, what's the possibility? 1 and 0 is the possibility. Everyone, the most of them, they given correct answer. Very good. Very nice. Keep it up. Okay. Now, move to next one. If the events A and B are independent, they given events are, I'm not going to do it on the board. You only do it and give it an answer within 1 minute. A and B are two independent events. They given probability of A complement value 2/3, probability of B complement is given 2/7. They're asking to find out what's the probability of A intersection B. You know that first you find out P of A and P of A value from the complement. How to find out? Probability of A complement. What's the probability of A complement? Is nothing but 1 minus P of A. Probability of B complement is nothing but 1 minus probability of B. From this you find out. Sorry, they given already complement value. I want to find out P of A. Sorry, P of A is nothing but 1 minus probability of A complement, and then P of P is nothing but 1 minus probability of P complement. Okay, yeah. And then you use the this one. Then both are independent. Therefore, from the multiplication theorem, probability of A intersection B is nothing but probability of A into probability B. Yeah, some two students they given answer. Shamini and Sweetie, correct answer. The answer is what? Actually 5/21. 5/21 is which option? First option. Given, even though some students still struggling how to do it further, I'm explaining on the board. Here I want A and B. From the complement, first you find out corresponding A and B happening value, and then independent from the multiplication theorem, we get product. Yeah. Some few students they given one also given answer correct. Yeah. This is way I think everyone those who are attending the class, everyone is clear. Condition probability with help of condition probabilities, whenever happening all the events at a time, how to apply multiplication theorem, two formulas have without independent or not independent. So carefully based on that using multiplication theorem, then simplify that and find out the solution. Thing is clear. We are moving to next is base rule. I think it's clear, no? Most of them they give an answer. Okay. Next is base rule. Base rule is actually one of very important rule. I'll tell you one thing. Is this rule, base rule I written on the board because I'm not explaining the proof. We are considered only a rule, theorem, statement of the theorem. That's why I written base rule. This rule, I'll tell you one thing, is a very much important in the all the stream, not only engineering, in medical also. They want to take addition. They're using base rule. This base rule is a very important concept. Take addition whenever having ambiguity, uncertainty. Because we are giving A slash B, we are asking B slash A. What's going on here? This is whether they are correct or not, like that. I'll give one simple example here. That is what I narrate that live example here. Yeah, I'm taking today online 1:45 to 3 o'clock probability class. My name is Dr. K.M. Rupa. My initial is KMR. Yeah. See, KMR is taking class means at least one of the student must be there in the class. Then only I'm handling the class. See, just you think in offline, not for in the online also. See, nobody's not there. I'm waiting 5-10 minutes. I'm going to log out. I'm not going to continue the class. At least one students are there. I'm going to continue the class. See, this is a thing ambiguity. I'm explaining base rule. Please try to understand this. See, in this class, KMR class is she's taking class means at least one student must be attending the class. See, probability of KMR class is depending upon students. Students are there, then we are calculating what's the probability of KMR handling probability class. Okay, therefore, my B is actually KMR madam is taking class. Is a B. Attending the students is nothing but A1, A2, A3, etc. Okay, fine. Okay. Attending the students are nothing but A1, A2, A3. Like that. Now, I want to find out probability of B. Which one is happening? What about that? A1, A2, A3 are attending. Then only we get probability of what actually B. Okay. And then please try to understand probability of B is depending upon what are the students are attend. Based on that, we are going to write the probability of B. Therefore, that is nothing but total probability of that P of B. You know that you have two even E2. Then P of B is equal to P of E1 into P of C. I want to write probability of B is nothing but the student is attend the class and then how much is listening the class is nothing but please try to understand B slash A1. Please try to understand A1 is there, then only I'm calculating what's the probability of attending KMR class. Is a one of part of the student. Next, second part of the student I'm going to write. I'm taking some, means attending up each of the students are not, is their own interest. Collecting all students sum that gives us the probability of the handing the KMR between 145 to 145 to 3 probability. Yes, okay, that is P of B. That gives us total probability. Now, while taking KMR, she is asking one question. Say just few minutes before I'm asking one question, you only have to give the answer. Now, while taking the class, I'm asking the question. Okay, asking one question. That question I'm asking for 20 now in my class, maybe some 20 students or 22 students are attending live. Okay, I'm asking one question in the class. one of the particular student giving answer. One of the particular student giving answer. That particular student giving answer means how is possible? Madam must be asking the question. That is nothing but probability of the particular student is answering in where? Answering in my class. That is AI. AI is nothing but maybe one of the student, maybe first student, second student, out of 22, maybe one of the student given answer. What is that? Probability of AI/B. Why slash becomes, see, he answers the question means the what's the thing is happened. Madam must be engaged the class, and then she engaged the class only. She is going to ask the question. She asked the question only. He is giving answer. Therefore, I want to know what's the probability of particular student answering my class means probability of A/B. I want to find out. It's nothing. That is nothing but probability of A/B. It's nothing but probability of the particular student. What is the particular student? AI into probability of B/AI divided by total probability. This gives rise probability, that gives rise the answer of probability of the particular student giving answer in KMR class. See how is ambiguity? Yeah. See, what we get here, probability, how we get this is nothing but actually, this is how we get probability of the particular student with B. See, both have happened, then only is possible to find out, right? Yeah. Class must be engaged, he has to attend. Therefore, but class engagement, students must be account. Therefore, that is independent. Therefore, probability of AI into probability of B/AI divided by total probability. Total probability is this. That gives rise probability of the particular student given answer in my class. Keep in mind. See, class must be must be going on. Class must be handling means student must be there in the class. Therefore, whenever I calculate probability of my handling the class depends upon the student. Therefore, each student attending the class I have to take. Therefore, sum of that probability gives us P of B. But while taking class, I'm asking one particular question. The answering that question in one of the particular student. That is nothing but probability of the particular student answering my class. To find out is nothing but probability of A intersection B divided by total probability. But A is not depending. Suppose students are there, class is engaged. There is no question arise for AI/B. Therefore, AI is independent compared to B. Then divided by total probability. This is ambiguity. This is a very, very important to take addition in the medical field, engineering course, especially for, they have 3 missions. I want to know which one production is very good compared to other mission. There we are using a Bayes theorem. Without Bayes rule, without Bayes theorem, you can't take a decision. So this is a what actually one of the uncertainty to overcome to adopt Bayes rule. See, Bayes rule, the give rise what actually posterior. Posterior means, you know, in the phone pay, there are 2 things. One is a post pay, you know, another one is prepaid. Prepaid and postpaid. Postpaid and prepaid. Like that, pre-year, we already know the probability. With help of know the probability, we are finding the next probability. That is called posterior. Whenever I want to find out posterior probability, there we have to use the Bayes rule or Bayes theorem to find out the posterior probability with help of pre-year. You know the payment of the phone, pre-year, prepaid, postpaid, like that. Posterior. This is whenever I want to find a posterior probability, there we have to, with help of pre-year probability, there we are using Bayes rule. I think is we are to overcome the ambiguity. AI/B is nothing but B/AI. This example is not given in any textbook. I narrated my own way. Then easy to, then we have to overcome your Bayes rule ambiguity statement or theorem. I think at least few students are clear what's a concept of Bayes rule or Bayes theorem. Anyone please put a message yes or no. Is anyone put a message? Okay, it's clear. Okay. Keep in mind what I given the concept that attending the class is not there in any. And my own interest. I narrate that example. Then easy to understand. Okay. Okay, fine. Thank you, ma'am. Shamini given answer, yes, ma'am. Okay. This problem they given in the question paper based on the base rule. Okay. This problem events even in E2 form a partition. They given instead of they having one sample spaces, they divide into two partition, E1 and E2. That's all. Partition of the sample space. Yes. A is any event such that probability of E1 equal to probability of E2 is equal to 1 by 2. Then probability of E2 slash A is nothing but 1 by 2, and probability of A slash E2 is nothing but 2 by 3. Then I want to find out probability of E1 slash A. Now observe carefully. I want to find out probability of E1 slash A. It's nothing but they divide into sample space in 2, no? Therefore, what is that formula actually? Probability of E2. Yes. Now just telling that probability of E1 into probability of I2, right? Ulta for this A slash E1 divided by, they divide sample space into how many? 2. Probability of E1 into probability of A slash E1 plus probability of E2 into probability of A slash E2. Right. We can't find out directly without knowing probability of A slash E1. They're not given probability of A slash E1. So first you find out probability of A slash E1 with help of probability of E2 slash A. They given already the answer, or they given the value of probability of E2 slash A. So from the base rule, what is probability of E2 slash A? Probability of E2 into the, you write ulta. What I'm telling that is actually crude method. How to write? You write numerator, means before the slash, into write the ulta of this. A slash E2 divided by how many partition they given? 2 partition. Like that, I write 2 partition. That what you written the numerator, write the same thing in the denominator. How many partition have based on that you have to write. That's all. This is the easiest way. If you want to overcome the ambiguity, I'm giving another alternative. What you are expecting. Here you have to write this is first, and then write the condition property ulta of this. That's all. E2 into probability of E2, what about A slash E. Okay. Using this, you have a value for this. What's the value for this? 1 by 2. What's the value of this one? Probability of E2 and E1, they given 1 by 2. A slash E2, they given actually 2 by 3. Okay, fine. E1 is 1 by 2, but they're not given this value, probability of A slash E1. And then what's the value of this is 1 by 2. A slash E2 is 2 by 3. Yes. Simplify that. You take cross multiplication and simplify that. We get probability of A slash E1. Right? Probability of A slash E1 is given for this. Okay. It's nothing but what actually probability of, you simplify that. I'm not going to do the simplification part because you know how to proceed, how to do it. Because I want to cover statistics part also. Probability of A slash E1, what is that actually? You take this as a cross multiplication, simplify that, we get 2 by 3. Once we get 2 by 3, you take this formula. Substitute all the values and then you get A slash E1, simplify that. Finally, we get answer. Probability of E1 slash A is nothing but 1 by 2. 1 by 2 means answer is A. I think everyone's clear. Yeah, somebody they were given 2 by 3 strong, ma, is 1 by 2. 2 by 3 is, yeah, you given probability of A slash E1. But again, you are doing confusion, ma. Confusion, ma. So that is one part. But they're asking E1 slash A. E1 slash A means again, I have to use twice base rule. Substitute this value here, simplify that, we get answer is 1 by 2. Is it clear, Saujanya? Okay, fine. Yeah, I think everyone is clear. how way I to write the ulta of this. What you are expecting, write the ulta of that in the numerator. What you are written in the numerator, how many partitions are there, you write it in the sum in the denominator. Okay. Yeah. Because they are not asking all the explanation in the CET, they are expecting only correct answer. Okay, fine. Okay. Yeah, a man speaks truth 2 out of 3 times. He speaks one of the natural numbers in the set of sample space 1 to 7 and reports that it is even. And it reports that it is even. The probability that it is actually even is a very clever question here. Actually even is. Yeah, what is the sample space they given here is 1, 2, like that, 7. Yeah, probability of even number. You know that how many even numbers are there? Yeah. Yes, what's the probability of even number? Suppose I'm going to take probability. Yes, the S1 denotes even, S2 denotes uh, okay, fine. What's the probability of S1 is nothing but 3. Number of number of cases getting to the even number is 3 divided by total number is 7. What is probability of getting odd number is 1 minus even is nothing but 1 minus P of S1 is nothing but 4 by 7. Okay. Now, and also, now I'm going to take EBA, one of the event, it denotes man speaks the truth. It denotes the speaking the truth. For my convenience, I had to choose E denotes the what? The man speaks the truth. What's the probability of E is they given? 2 by 3. They given probability of what about that? This is C. The man C. No. 1 minute. This is not correct. E denotes the man speak the truth. Okay. But a man speaks the truth 2 out of 3 times. He speaks one of the natural number in the set and reports that it is even. And reports that it is even. Continuation. He speaks one of the natural number times, but it reports is the what actually it is even. It is even means what? Probability of even must be happen, and then he speaks the truth. This is a value they given. Please try to understand probability of even number out of even number. How many times he speak the truth? A man speaks 2 out of 3 times. He speak one of the natural number and report it is even. Means he speak the truth is what he counted is nothing but what? Even number. Therefore, out of the number of evens, how many times he speaks the truth is nothing but what? 2 by 3. Then probability of E slash S2 is nothing but how many times he speaks whatever that true in odd numbers is nothing but 1 minus 2 by 3 is nothing but 1 by 3. Please try to understand. It's very tricky for this. Now, and it is reports is even means out of how many even number he speaks the truth. What a man speak the truth is 2 out of 3 is nothing but even. Therefore, what is probability of E slash S1 is nothing but 2 by 3. From that, we get probability of E slash S2 is nothing but odd number is nothing but 1 by 3. Next, what are they expecting? The probability that it is actually is even. Means he speaks the truth first and then he counted whether, then he observe is the counted whether they speak even number or odd number. If you want to count it, first you have to speak the truth. That comes first. Speaking the truth is come first. The probability that it is actually even. It is actually secondary. But if speak the truth is come. Once speak the truth, then that truth is actually is nothing but what? Even. Is even means what? Probability of S1 slash E1. What is probability? You do one thing. Suppose you confusing these things, observe the question. First you write the question. I'm telling in the class also for the students like that. See, he reports it is true. It is even, okay? He speak the truth, it is even. The probability that it is actually even. It is actually even means he talking about speaking truth comes first. But That is speak what actually E1. E1 means what? S1 slash E1. I want to find out S1 slash E1. What is the formula? I told the formula for this ulta S1 into ulta of this probability of E slash S1 divided by probability of S1 into probability of E slash S1. So how many have E1 and R? Therefore, I take 2 S probability of S2 into probability of S slash S2. Yeah. Next, you have probability of whatever that S1 and S2. Yeah, probability of see out of how many number even number we get a probability of S1, S2 we get very easily. But probability of E slash S1 now easy to take 2 by 3. Have 2 by 3, then what is probability of E slash S2 is nothing but 1 minus 2 by 3. Suppose you confused to take this, first you write what they're expecting in the problem. What they're expecting the problem is nothing but probability of S1 slash E. You apply the base rule first. And what they're expecting the data you take from the problem. Then you have to overcome the ambiguity. I think it's clear, this part. Then substitute and simplify. Finally, answer we get 3 by 5. 3 by 5 so D is the answer. Yeah, D1. Yes, correct, ma. Yes, sir. D is the answer. 3 by 5 is the answer. Very good. Manu, Saujanya, Meena, they given very correct answer. I think it's clear. I'm requesting it once again, while solving a base rule problem, first you apply base rule. And then what they're expecting in the right hand side to write the what about value of the right hand side, you pick from the question. Then you have to overcome the ambiguity. These two are okay, but while writing that, then easy to write probability of E slash S. Yeah?
Right, sir.
E slash what about S1 and E slash of S2. Observe carefully and then take carefully. Probability of, please don't disturb the class. E slash S1 and probability of E slash S2. Okay, fine. Hello? Please don't disturb the class. Chemistry faculty, I'm requesting once again, still have 7 minutes time. Please don't disturb the class. Okay. Okay, no, not issue. It was base rule. Okay. I'm not clear what you are saying, Manu. It was base rule. No, what I written the headline is correct, sir. We don't have Y. You don't have Y. Manu, no. What I written is correct. Actually, there is no I. There is no I. Manu, I'm telling there is no I. Sorry. Manu, I'm telling you, please give me a response in the chat box. Okay. Next, I'll move to the statistics. They still have 6 minutes time. I think, okay, Manu. Okay, bye. Okay, thank you. See, I think at least you give 1 or 2 students in chat box. Are you clear base rule? You please what they're expecting in the problem, you write it the question. Apply carefully base rule. Write the ulta of that. Okay? Okay, thank you. Then I move to have time of 6 more minutes. Nobody start put a message or what is clear base rule or not? Please give it quick. Suppose you give quick answer, I move to the next for statistics. You know statistics, even though I'll give a quick glance for what are the given questions up to till 2014 from 2020 I'm covering. Standard deviation of the data. See, you know what is standard deviation formula? What's the standard deviation formula? Square root of sigma xi minus x bar whole square divided by n. Given only a data, therefore, what is a mean? X bar is nothing, sum of all the values divided by number of values. Using this, you find out the mean. The mean value after the simplification we get, and then root of what is the n value? How many values you have? 5, 1 by 5. And then you take a difference. First value 6 minus 8 whole square, and then 7 minus 8 whole square, like that you Take a different square of that, simplify that. Finally, we get root 2 is the answer. One student given the answer. Good. Yes, correct. C is the answer, right? That's why I'm covering the last because statistics very easy. You know the formula and then you do it. Mean and standard deviation of 100 items. 100 item means what? N is equal to 100. Or mean means x bar, they given 50, and standard deviation, they given 4. What is sum of all square of the items? Keep in mind, just now I'm written standard deviation, one formula, square root of sigma xi minus x bar whole square divided by n. You have an alternative formula for this, is nothing but 1 by n into sigma xi square minus x bar whole square. This is the alternative formula. Here they are asking sum of all the square of the items. X1, X2 are nothing but items. They are asking sigma xi square. Therefore, you can't take this formula. We are going to take this formula. While taking this formula, keep a square in the right hand side, left hand side for temporarily sigma xi square minus sigma, x bar whole square. Now I have to take sigma square plus x bar square whole square into n. Is give rise sigma xi square. Sigma xi square is nothing but sum of the square of the items value. Substitute sigma 16. Sigma x bar they given, what's the value? They given 50, 25,000. Means 2516. N is 100. Multiply that. What's the answer? I'm doing orally only. What's the answer? What's the answer? This is 16. This is 25,000. What is that? 2516 into 100. Yes. What's the answer? Which one? A is the answer. Right? A is the answer. I think is clear. Please give me a quick answer. Yes or no? Yeah, this is alternative formula. See, using standard deviation, observe carefully what's the data they provide in the problem. Based on that, either choose first one or second one. Here they're asking the sum of all the square of the items. Therefore, I'm using second alternative formula. First, I'm remove the square root. I'll shift the x bar in the left hand side, and then I have to take 1 by n as a cross multiplication. Okay. Okay, fine. Now, I move to next quickly for next one, third one. If the coefficient of variation is 60 and standard deviation is 24, then arithmetic mean. Then you know CV. CV means what? Coefficient of variation. What's the formula? Sigma by x bar into 100. With the help of that, you find out what is x bar. X bar is sigma by CV into 100. The given sigma value is 24. And then they given, this is they given 24, the CV they given 60, substitute and simplify. Tell me quick answer. What's the answer of this? What's the answer? Please. Please give me a quick answer. Coefficient of variation formula written on the board. Yeah. It's a 40. 40 means which option is? Option A is the correct answer. Okay. Yeah. Better you practice to give an answer in terms of option A, B, C. Don't put a 40, 50 like that. Because you practice like that. While doing the practice, you write the answer is A, B, C, D like that. Sometimes they're giving 1, 2, 3, 4 like that. To go through the CET question paper. Yes, you write that way answer in the chat box. You do the practice. Don't write the original answer. Okay. Yes, that is nothing but A. Is it clear? I think. Okay. Move to the next and thing that's very simple. The quotient of variation of two distributions are 60 and 70, and standard deviations are 21 and 16 respectively. Then their means. You know that I just now I explained for one. They're asking they're given two. I have to write a quotient of variation for sigma 1 by x1 bar into 100 for 1, and quotient of variation for sigma 2 divided by x2 bar into 100. Using this to find out x1 bar and x2 bar. We get x1 bar and x2 bar. I'm not going to do it on the board because you know how to do it. But the x1 bar we get based on the first data. I taken here CV 60 and corresponding standard deviation is 21. X1 bar is 35 and x2 bar we get 22.85. They are not provide both the values. Yeah. Here they provide separately. A very ambiguity here, right? The right answer is and B is the answer. They given different. This is the way they given in the question paper. A and B is the answer. Yeah. If you can't write sweetie only one answer, no, you must be write both answer. And D is the answer. Okay, I think it's clear, everyone. It's a last one. Quick glance for the last one. Yeah. That one you know how to do it. Yeah, this is a mean deviation. You know formula for mean deviation. Sigma mean deviation formula is nothing but sigma absolute of xi minus x bar divided by number total number. Absolute means either may be difference, may be negative or positive. Take it as a positive value. First, you find out the mean sum of the values divided by number of values. You take absolute. Either maybe we get a difference or negative or positive. Why we are taking absolute? Without absolute, suppose your mean value is a whole number. There is no round of value. That sum of this, that's a mean property. Sum of xi minus x bar value must be 0. That's why the absolute value. Even though what about the absolute the difference, we are taking absolute value. Negative or positive, take it as a positive. Yeah, definitely you don't get it 0. If you want to verify that, suppose we get a whole number, take the without absolute, take the sum of difference value, we get 0. Then answer they already written. This is the answer correct. Mean deviation answer is correct. Everyone is clear for this part. Okay. I think I covered because I'm not covered discrete random variable distribution and binomial distribution because it's deleted from CET syllabus for because due to pandemic issue they reduce some portion. You don't have a discrete and random variable binomial. That's why I'm not covering that. Apart from that, yesterday Gnaneshwari she covered. Therefore, today I took 10 to 15 minutes more for that thing. Why? Because I took complete. Yeah, tomorrow you don't have a math class. What we are have a target for CET. We covered the portion. What our best possible in our department for each one every faculty best what they based on their knowledge they explain. I don't know how many students are convinced or not. Suppose you are not convinced any step from anyone, please give excuse for our department side. I'm asking once again for everyone. And thank you very much for listening. Suppose we did any mistake, anything, you please give excuse because in online maybe happen for us. Thank you very much. We are bye, see you and take care. All the best for your mock exam maybe on Monday and Wednesday, and also all the best for your CET exam. We are looking forward for everyone, those who are listening online or those who are listening through YouTube stream. We are looking in the BNP. We are expecting all those are logging in online or we are using YouTube. We are expecting these students looking forward in our college. We are giving most important for application, especially for mathematics. If you want to, Dr. K.M. Rupa have one channel or in the website, we are share so many things and also have e-Shikshana. Tomorrow is possible. I'm sharing that e-Shikshana link. We covered so many applications. We are giving much important for application. We are expecting the students in our BAT. We are looking in the BAT for everyone manually. Thank you very much. Bye. See you.
Thank you, ma'am.
Okay, thank you. ಮುಗೀತು ಒಂಚೂರು ಊಟ ಮಾಡ್ಬೇಕು ಹೇಳಿ ಏನು ಮಾಡಿ.
Prakriti ma'am, you can start now.
Hello. Hello.
Good afternoon, students. Session will start another within 2 minutes. Yeah, good afternoon, students. Are you there? Are you there? Good afternoon, students. Hello. Hello, are you there? Students? Can you please drop a message in chat box? Are you there? Hello. Okay, I'm going to start. I'm going to discuss today few questions on coordination compounds and D and F block elements and coordination compounds. You know, from D and F block elements and coordination compounds in your CET. So you'll get more questions, minimum 6 questions. I think you'll get 6 questions. So we'll discuss few questions. Okay. Are you there? All of you getting what I'm explaining? Hello, students. Please drop a message in chat box. Hello. Are you there? Okay, we'll start from question number 1. That is, first identify the set of paramagnetic ions among the following. So here you can see this is titanium, copper, and manganese. For all the 3 elements, oxidation state is +3. Scandium, titanium, vanadium, and here also oxidation state is +3, and here the oxidation state is +2. Vanadium, cobalt, and zinc. Here the oxidation state is +2. Nickel, copper, and zinc. Now, students, can you please tell me which is the answer? Whether A, B, C, or D? Hello, students, are you there? Students, so which one is the answer? So here, you know, the ions which contain unpaired electrons. So, you know, paramagnetic and diamagnetic depends on if in the elements containing or ions containing unpaired electrons, such ions exhibit paramagnetic in nature, and the ions does not containing unpaired electrons, that will not show paramagnetism. Let's see. So such ions we called as diamagnetic in nature. Here the ions which contain unpaired electrons that exhibit paramagnetic behavior. Let's see the electronic configuration for all. Here in the answer 1, that is A, titanium 3+, copper 2+, and manganese 3+. First, let's see this. Here the configuration is 3D0, that is actually 3D3 for titanium. Here 3+ is there. All the d electrons are, there is no d electrons, all the d electrons are lost, that is why 3D0. Here 1s2, 2s2, 2p6, then 3s2 and 3p5. 3p5 means one unpaired electron. Total in p there are 6 electrons should be there. 6 electrons should be there. That means one unpaired electron is present in 3p, that is titanium. And copper 2+, Cu2+, you know, that is 1s2, 2s2, 2p6, 3s2, 3p5, 3d9. Here also one unpaired electron is present. Total complete here it is to come for completely filled 3D orbitals, 1 electron is required. Total 10 electrons are there in 3D. So here 9 electrons are there. That means it requires one more electron to obey complete octet. So that means here it is having one unpaired electron. Manganese also, you can see here at the end. So 3D4 is there. 3D4 is there. There are 4 unpaired electrons are present. Thus, all of them have unpaired electrons. Hence, you can come titanium, copper, and manganese exhibiting paramagnetic in nature. So let's see other B, C, and D. Why it does not exhibits paramagnetic in nature? We'll see. Titanium 3+, here in B, titanium 3+, this is also having unpaired electron. And scandium does not have unpaired electron. Otherwise, we'll come to the vanadium 3+. It does not possess any unpaired electron. Vanadium does not having any unpaired electrons. That means this answer is wrong. And you just come to the vanadium here. Vanadium Zn2+. You just go to the Zn2+. So Zn2+ it does not containing any unpaired electrons. Then this is also not contain. This is also this answer also we are going to rule out this answer. And the fourth option here also Zn2+ does not contain any unpaired electrons. Hence this answer also we are going to rule out. And what is the answer for this question? Students, what is the answer for this question? Hello? Students, what is the answer for this question? Answer is A. Okay. Please drop a message and in a chat box, students. Hello, students. So I didn't. Yeah, in the chat box. Yeah. Okay. Option A. Okay. Right. Now we'll go to the second question. Answer is A for the first question. Then we'll go to the second question. Here, how many moles of dichromate is required to liberate 6 moles of iodine from an aqueous solution of iodide? See here, that is in transition metals, one of the important compound is dichromate and potassium. Dichromate is the one of the important compound. Here, dichromate, it is a strong oxidizing agent. It is a strong oxidizing agent. Oxidizing agent means itself undergoes reduction. It oxidizes other species. It oxidizes other species. So when it oxidizes other species, it liberates those species, liberates electrons. Those electrons are accepted by this dichromate. So such compounds are called oxidizing agent, and it is a strong oxidizing agent in presence of acidic medium. So we'll write the reaction. See here, how much mole of iodine dichromate is required to oxidize 6 moles of I2. Let's see the. So here balanced redox reaction will be. So just sorry. Balanced redox reaction. So 3 moles of I2 requires 1 mole of dichromate solution. So then 3 moles of iodine, I2 requires 1 mole of dichromate. Then 6 moles of I2 requires how much? That is 2 moles it required. Then answer is, what is the answer here? Answer is 2. So now we'll come to the second one, that is third question. The number of moles of electrons required. Here the second question is different. Here the third question is different. This is second. In the second question, we have calculate how many moles of dichromate is required to oxidize that I2 into I minus into I2 into I minus. Okay, now we'll go to the in the third question, moles of electrons required. Here this is a redox reaction, oxidizing agent, strong oxidizing agent, dichromate, it oxidizes. So when it oxidizes, other species itself undergoes reduction by accepting electrons. Then let's see how many electrons are involved in the reaction, or how many moles of electrons involved in the reaction. Here you can see the number of moles of electrons required to reduce 0.2 mole of Cr2O7 minus 2 to Cr3 plus. Then what is the answer for this? What is the answer for this? What is the answer for the students? Answer is C. Priya. Okay, Shravani Priya. Answer is C. Okay, let's check whether your answer is right or wrong. Here you can see the reaction Cr2. Here oxidation is 6 plus. Oxidation is 6 plus. So reduced into the 3 plus. So it accepts 3 electrons. It accepts each Cr 6 plus is there. So here 2 Cr 6 plus is there. Is that clear? 2 Cr 6 plus is there. That means 2 Cr6 plus ions are there. That means each Cr plus 6 accepts 3 electrons, gets reduced into the Cr3 plus. That means total 6 electrons are required. Here 1 mole of dichromate requires 6 mole of electrons, that is 0.2 mole required to oxidate, that is required 6 mole of electrons. In that 0.2 mole is required, that is 0.2 into then 0.2 mole requires how many moles of electrons? Then 0.2 mole of dichromate requires how many moles of electrons? That is 0.2 into 6 divided by 1, we will get 1.2. Your answer is correct. That is answer is B. Okay, answer is B. Then the elements in which electrons are, fourth question, elements in which electrons are progressively filled in 4f orbital are called as. So in which case electrons are filled in 4f orbital, whether it is transition elements, actinides, halogens or lanthanides, in which case 4f orbital is exist. In transition elements, what is present? What is the answer here? So in lanthanides, the electrons are filled in 4f orbitals starting in the initially. So 4f orbitals, while in halogens they are filled in p orbitals, and the transition elements electrons are progressively filled in d orbitals. Hence, what is the answer here? What is the answer for this question? Here the answer is D, that is lanthanides. Now we'll come to the fifth question. Incorrect statement with reference to cerium. With reference to cerium, Z value for cerium is 58. You know that. So what are the statements? Let's see. A. Cerium in +3 oxidation state is more stable than in +4 oxidation state. Then B. Cerium +4 is a reducing agent. Then cerium shows common oxidation states of +3 and +4. And D's atomic size of cerium is more than that of lutetium. Let's see here. They are asking, you need to concentrate here. They are asking about incorrect statement, which is not correct regarding cerium. Let's see which one is. See here, we'll go to the one by one. Cerium will exhibit +3 oxidation state. Yes, of course, it exhibits +3 oxidation state. Let's see the answer. Just I'll explanation. Cerium +3, cerium +3, cerium +4 is an oxidizing agent, since it cannot. See, cerium +3 oxidation state is more stable than in +4. When it is in cerium exhibit +3 and +4, both the oxidation states. So that is also correct. Cerium +3 is more stable. Almost all the lanthanides exhibit +3 oxidation state, and it is more stable oxidation state, So hence +3 oxidation state is more stable. Then you just come to the cerium shows a common oxidation state, that is it exhibits both +4 and +3. And atomic size of cerium, obviously it is more than that of the lutetium. Here you can see here answer is B. Why it is B? Because when it is in +4, it behaves as oxidizing agent. So since it cannot attain oxidation state higher than +4, due to why? Because it cannot attain oxidation state higher than +4 due to decrease in stability at higher oxidation state. So it is not going to show stability. Hence, it acts as a oxidizing agent at +4, and it does not behave as an reducing agent. Okay, so here a mixture of sodium chloride and potassium dichromate is heated with concentrated sulfuric acid. You'll get deep red vapors. Deep red vapors are formed. Which of the following statement is false here? Do you know the chromyl chloride test? I have explained in the previous session, that is chromyl chloride test of dichromate. Okay, let's see here. The same, they are given question given on that chromyl chloride test. Here the vapors contain CrO2 Cl2 only. The vapors gives a yellow solution with NaOH. The vapors when passed into the lead acetate in lead acetic acid, so it gives a yellow precipitate, and vapors contain chromium chloride, CrO2 Cl2 and then Cl2. Which statement is wrong here? Which statement is wrong? So the vapors containing CrO2 Cl2, it is correct. Then vapors gives NaOH. You can see here the reaction. So I have written the reaction here. Your dichromate treated with NaCl. So in presence of H plus ion, you will get chromyl chloride, CrO2 Cl2. Then first answer is correct. Then when it is treated with NaOH. When it is treated with NaOH, you'll get so water, you'll get water. Then again this CrO4 2 minus, again chromate, sodium chromate will be formed. This sodium chromate is treated with lead acetate, you'll get lead chromate precipitate. You will get red chromate precipitate. This is also correct. Yellow solution with NaOH. Then vapors then passed into the lead acetate, you will get yellow precipitate. That is also correct. Then see which one is the wrong statement here. Here the vapors containing chromyl chloride and chloride. This is the wrong statement. You can observe here by observing the reaction you'll come to know that. What is the answer here? What is the answer here, students? What is the answer? Yes, answer is D. Okay. Let me check. Answer is yes, answer is D. Correct. Very good. Then we'll go to the next question. So which of the following statement is wrong here? So here manganese 3 plus and cobalt 3 plus are oxidizing agents in aqueous solution. So in the highest oxidation states, the transition metals show acidic character. All elements of 3D series exhibit variable oxidation states. And then metals in highest oxidation states are more stable in oxides than the fluorides. So one by one we'll see. So here so what is the answer here? Mn3 plus and CO3 plus are oxidizing agents. So cobalt at 3 plus oxidation, it behaves as oxidizing agent. Mn and 3 plus oxidation state, it behaves as oxidizing agents. Okay, this is because this is also, these elements also exhibiting higher oxidation state. Then we'll come to the, in the highest oxidation states, the transition metals show acidic in character. You have seen that when the highest oxidation state, how it behaves. When it is in lowest oxidation state, how it behaves, I explained. When in between the highest and lowest few oxidation states are exhibits, so elements will be exhibiting, so that will show, that will behave as ampotric in nature. So all the elements of 3D series exhibits variable oxidation states, of course, but very some elements will not exhibit that. Let's see that. So metals in highest oxidation states are more stable in oxides than in fluoride. This is also correct. Let's see the answer. Zinc contains completely filled d orbitals and exhibits stable electronic configuration. Therefore it does not easily lose their electrons, hence does not exhibit variable valency. That is why I told no, see, all the elements of 3D series does not exhibit variable oxidation state. Is that clear? Even though scandium also, that is exhibiting only one oxidation state, that is +3, it is more stable. Then what is the answer for this, students? Answer is C. For this, answer is C. Then we'll go to the question number 8. Here in question number 8, which among the following is the strongest ligand? So on what basis, how we are going to decide the strength of the ligand? Based on the spectrochemical series. What do you mean by spectrochemical series? Arrangement of ligands based on their strength. That is called as spectrochemical series. You know, so that I have given a hint in case of spectrochemical series, how to remember. For that I have given an hint. That means first carbon ligands are more stable, then nitrogen ligands, then followed by oxygen ligand, at the end halide ligands. Okay, halide ligands. You can see here ammonia, it is a nitrogen ligand. Cn minus, it is a strong ligand, that is carbon ligand, it is a strong ligand. Ethylene diamine, it is also again, it is a nitrogen ligand. And CO, so in the spectrochemical ligand, a very ligand having highest strength is, that is CO. We have CO, they have placed in the spectrochemical ligand, spectrochemical series, CO they have placed first. So that means CO exhibiting very high strongest ligand. CO is the strongest ligands. I'll just show the spectrochemical series in the next. That means answer is here CO is the strongest ligand due to the synergetic effect. What do you mean by synergetic effect? That is back bonding. So CO, CN, even sometimes CN also, it is also involved in back bonding. But compared to that, CO back bonding is more. In this effect, you know that some of the bonds are self-strengthening in nature. So when pi back donation of electron density occurs from one atomic orbital to the another, antibonding, that is metal donates electrons to the antibonding orbital of the ligand. So that is called as back bonding. Because of this synergetic effect, that is CO is a strong ligand. Here the formula, see, this is I have explained some points regarding how to name coordination compounds. So according to that, first we need to name cation, then followed by anion. Is that clear? In the different ligands are there, more than one ligands are there, what we have to do, we have to name according, we have to choose the ligand according to their according to the alphabetical order. Here aqua is there, nitro is there, so you have to choose, first you have to name with the aqua, then followed by nitro. Let's see. Form, that is penta aqua nitro, that is formula for penta aqua nitro chromium 3 nitrate is which one? Which is the correct formula for this coordination compound they are given, that is penta aqua nitro. So here you can see penta aqua. So first answer is ruled out because here hexa aqua is there. B, hexa aqua is there. This is also ruled out. Come to the C. You just concentrate on C and D because in both the cases penta aqua is there. Penta aqua nitrato. Penta aqua nitrato. Then nitrato and chromium 3. In both the cases, so which one is having chromium 3? Then nitrate. So just I'll do here. So prefix penta indicates the presence of 5 H2O ligands. The name of the ligands are written in the alphabetical order. Then the answer is D, that is pentahequo nitrito. Here nitrito, what we, for which element we called as nitrito, that is NO3. Then NO3 twice. Here NO2 is nitro. It is nitro. It is nitro, neutral ligand, it is nitro. So now the answer is D. For the redox reaction, here they are given redox reaction. We need to write the, this is a, we have stoichiometric composition. We need to write stoichiometric ratio here. MnO4, just I'll see for the redox reaction, XMnO4 minus YH2C2 oxalato, that is we are going to treat it with zinc H plus ion. We will get Mn2 plus NCO2 PH2O. Skeletal equation I have written here. MnO4 minus H2C2O4 Mn2 plus and CO2. So here C oxidized into 3 plus into 4 plus, that is H in H2C2O4. It is the reducing agent. Then Mn plus 7 to plus 2 oxidation state, that is reduction here. First one is oxidation, second one is reduction. So we are going to balance the equation. So I'm going to the last equation. So here you can see that is H2C2, the last equation for this final balanced redox equation. H2C2O4 plus 2MnO4 minus plus 6H plus gives rise to 10 CO2. Here just we are going to balance the equation. This is very simple for you people. So you just, how many H2 present in the right hand side, same H2 we need to balance on the right hand side and left hand side. So same I have written here, 5, 2, 6, 10, 2 and 8. What is the answer for this? What is the answer for this? So answer is B. Okay, is that clear? You can see answer here 2, 5, 2, 10. So which of the following oxidation state is common for all lanthanides? What is the common oxidation state for lanthanides, students? What is the common oxidation state for lanthanides? What is the answer for this? Hello, students. What is the answer for this? 3 plus 3. Very good. Plus 3 is the oxidation state. Very good. So what you said is correct. So common oxidation state for lanthanides is plus 3 because it is more stable. So at this stage, the oxidation state, when it is in, when the elements are having lanthanides exhibiting plus 3 oxidation state, these are all more stable. Lanthanides consists of elements in the F block of period 6 in the periodic table. Lanthanides most common and stable oxidation state is plus 3. It is obtained by removing 3 outermost electrons from 6s orbital and 1 electron from 4f orbital. Removal of one more electron from the 4f subshell is difficult to because of its high energy difference. Okay, which of the following is an ampotric oxide? Which of the following is an ampotric oxide? Ampotric means it is in between and acidic and basic. So ampotric oxides can react with both acid as well as base. It will form salt and water. The elements also it is have some metals, so those some of the metals and non-metals both exhibits this ampotric oxide, ampotric ampotric nature. So in that ampotrism based on the oxides of oxidation state, based on their oxidation state, we are going to tell. What is the answer for this, students? What is the answer for this question? What is the answer? Answer is A. You're telling answer is A. Let's see that whether what you said is correct. Yes. Yes, both Cr2O3 and V2O5 are ampotric in nature because of their high oxidation state. So when because of their high oxidation state in the coordination that is while explaining in the previous session I have explained. So chromium and vanadium, those are exceptional cases. So based on their oxidation state, we have different compounds having higher oxidation state, it behaves as acid, and lower behaves as basic, like that we have classified. So in that, so here plus 3 and both are exhibiting plus 3, that is why, so that is we are exhibiting higher oxidation state. V2O5 reacts with the alkali as well as acids. It give VO4 3 minus and VO4 plus respectively. Chromium also, Cr2O3, that is chromium oxide. It insoluble in water but dissolves in acid. It produces hydrated chromium ions. So the oxidation state here, it dissolves in concentrated alkali also. That means answer is A. So IUPAC name of CONH3 4 times Cl NO2 Cl is. What is the IUPAC name for that? What is the answer for this? Students, what is the answer for this? What is the answer for this? A. Okay, Veena, let's see. What is the answer for this? So first, first we need to write cationic complex, then followed by anionic part. So here after that we need to write the ligand's name, that we need to use prefix. So ligands we have to write based on their alphabetical order. Then we need to choose the what we have to do. Prefix we have to use here, how many number of ligands are present in that, then name of the metal, central metal atom. So here for ambidentate ligands, here we use N, that is before the name of the metal ion, because of the nitrogen of NO2 ligand is directly attached to the cobalt metal. So after the name of the metal ion with oxidation state in Roman number, then anionic ligand we need to name. So here IUPAC name of, so for that we need to know about the oxidation state of the metal. So let's calculate the oxidation state of the metal here, that is cobalt. We need to calculate oxidation state, that is X plus. Ammonia is a neutral ligand, there is no charge for that, hence it is 0, and -1 for nitro and -1 for Cl. Now you just calculate -1 plus, that is minus, then the whole it is a cationic complex, that is +1 is there, +1 is there because counter ion Cl minus is there, Cl is there, Cl is there. So hence What is the oxidation state for the whole complex is +1. So here -1 -1 -2, you just take that -2 into right hand side, that is +2 +1 +2 +3 is the oxidation state. That means here tetraamine. So chlorine is a negative ligand, that is a negative ligand. So hence we have to use that is O at the end we need to designate as O, that is tetraamine chlorido nitrito N. So here already I told it is an ambidentate nitro. It can form bond with the through nitrogen also and through oxygen also. Both atom donor atoms are present, but here it is bonded through nitrogen. How we are going to calculate this, madam? Based on their 18 electron rule. Based on their 18 electron rule, that means whole complex should obey 18 electron rule. So when it is in bonded with through hydrogen through nitrogen, so sometimes it is a one base different donor atoms are there, nitrogen and oxygen. When it is bonded to the nitrogen, 3 electron donor. When it is bonded to the oxygen, 1 electron donor, like this it is different. So donation of electrons are different when it is bonded with the nitrogen or oxygen. So hence based on that we are going to calculate that. So here it is bonded through the nitrogen, hence we have to take that is chlorido dinitrito N cobalt 3 chloride. Answer is A. Okay, Veena, your answer is correct. Electronic configuration of transition element X is +3. The oxidation state is +3. The oxidation state is 3d5, which is the atomic number. What is the atomic number for this? Argon is there, 3d5 is there. So oxidation state of that metal is +3. Then what is the atomic number for that scandium? It is, that is electronic configuration of that, it is +3 is Ar3d5. So before the removal of electron, when it is in +3, so it is 18 plus argon 18 plus 5 plus 3, that is 26 electron. Atomic number of X is 26. Solution is B. Then KMnO4 acts as an oxidizing agent in alkali medium. When the alkaline KMnO4 is treated with Ki, iodide ion is oxidized too. What is the answer for this, students? What is the answer for this? Yes, Veena. Good, Saujanya. What is the answer for this? B. Okay, Priya, Shravani, Priya, B. Right, your answer is, let's see the answer whether B is correct or not. Yes. When it is treated with iodide, we will get iodide ion. It is oxidized to iodate ion. What is the iodate ion? Formula for the iodate ion. You can see the reaction itself. Iodide ion, it is treated with MnO4 minus, get oxidized into the iodate ion. Iodide to iodate ion. Then what is the answer? Answer is C. Okay. So here two complexes they have written here. Here which one is exhibiting, see, in both the complexes, it may be it exhibiting linkage or geometrical isomerism or optical isomerism or hydrate isomerism. So we'll go to one by one. Linkage isomerism, we'll go to that later. So first we'll go to the, if water is present in the complex, no, there is no water, then hydrated isomerism is ruled out. Optical isomerism means, is that containing any cis and is it going to exhibit any cis and trans uh, compound? No, that is also not possible. Geometrical isomerism, no, it is not exhibiting any geometrical isomerism. Mainly it exhibits linkage isomerism, because you can see there. So FeNO2 thrice, it is linkage through nitrogen. Ambidentate ligand is present. NO2, it is an ambidentate ligand. So it has two donor atom. It can link through nitrogen as well as oxygen. In the second case, they have shown here ONO thrice. That means linkage here through O, linkage here through N. That is why it is exhibiting linkage isomerism. It is exhibiting linkage isomerism. It is, you can see just by observing itself, we can say the answer. What is the answer for this then, students? A. Answer is A. Very good. So the magnetic nature of elements depends on the presence of unpaired electron. Identify the configuration of transition elements which shows the highest magnetic moment. So which is having more unpaired electron, that exhibits highest magnetic moment. You can hear 3d7. 3d7 means 5 plus 2. That means it containing 5 plus 2, 3 unpaired electron. In this case, 5 unpaired, 3d5, 5 unpaired electron. 3d8. So how many unpaired electron? 2 unpaired electron. 3d2, 2 unpaired electron, which is having more number of unpaired electron. 3d5 is having more number of unpaired electron. When it is having more number of unpaired electron, it exhibits what it exhibits? It exhibits highest magnetic character. So 3d5 has 5 unpaired electron, therefore the magnetic moment is highest. Answer is B. Okay. So here, which of the following statement is wrong regarding lanthanides? Lanthanum 3, that is Ln3 compounds are generally colorless. Ln3 compounds are predominantly ionic in character. The ionic size of Ln3 ions decreases with increasing atomic number. Ln3 hydroxides are mainly basic in nature. So this is also correct. Lanthanum hydroxides are basic in nature. So this is also correct. Ionic size decreases. This is also correct. Statement 3 is also correct. Then we'll go to Ln3 compounds are predominantly ionic character. Yes, it is also correct. So Ln3 compounds are generally colorless. This is wrong statement because lanthanides exhibits colors. It contains unpaired electrons. DD transitions are there. DD transition, because of the presence of unpaired electron, there is a DD transition. When the DD transitions are present, so you can see the, what is the answer for this, students? What is the answer for this question? Yes, Shivani, Veena, what is the answer for this? Yes, answer my question. What is the answer? Hello, students. Yes, Jivita, answer is A. Okay, right. Let's see the answer. Yes, it is a lanthanides are generally colorful since vacant orbital transitions are it containing electrons. That is why DD transition will take place. Because of DD transition, it will exhibit the color. Okay, answer is here. This wrong statement is A. Square planar complex of the type MXBL. That is, all the 4 ligands are different. All the 4 ligands are different. Okay, shows the following set of isomers. It exhibits 2 cis or 1 trans or 2 trans, 1 cis, 2 cis, and 2 trans, 3 cis or 1 trans. What is the answer for this, students? What is the answer for this? What is the answer for this, students? Yes, Jivita, Shravani, Veena, Saujanya, what is the answer? Yes, answer is, you're telling A. Let's see what is the answer for this. So here you can see how to know, madam, this. First, what you are going to do, when all the 4 ligands are different, you just fix one ligand and you just change the all the 3 ligands. You just fix A here. So A, B, you can write here X, B, L. Then so here trans for A, trans is B. You just come to the second diagram. Here you can see fix A here. Trans is L now, then trans is X. You can see here. So in it is exhibiting mainly 3 isomers. It exhibit when the metal having in square planar metal having 3 different ligands. It exhibits mainly 3 isomers. So here which one is cis? Here in this case 2 are cis and 1 is trans. You can see here. You can see here AX are same side. AX are same side and AX is in opposite side. So that is why 2 cis forms and 1 trans. You can see the answer now. Complex is shown below, so it can show 2 cis and 1 trans isomerism. What is the answer for this? Answer is A. Okay, answer is A. Go to the next. According to the crystal field theory, that is ML bond is a bond in a complex is purely ionic, purely covalent, purely coordinate, and partially coordinate, partially covalent. What is the answer for the students? What is the answer, Jivita? A. Shravani Priya. Okay, yeah, let's see. What is the answer for this? Let's see this. According to crystal, that is purely ionic. Why it is purely ionic? Because in the last session I have explained coordination compounds. It is an electrostatic model. It is an electrostatic model. There is an electrostatic interaction between the ligand and metal. Here the ligand we are considered as a point charge. Is that clear? Here that is taken as an ligand. They are treated as scientists treated as point charge. Hence this is an they called as electrostatic model. Hence it is in. So the bond between metal and ligand is a purely ionic in nature. Purely ionic in nature. What you said, let's see. Ml, metal and ligand, according to the crystal field theory, Ml bond is purely ionic in nature because there is an electrostatic interaction among the metal ions and the ligands. So here the answer is A. Your answer is correct. Good. Coordination number and the oxidation state of the element M in the complex. So they are given the complex here, but we have to find out the metal, which metal, and sometimes they may ask in this case, they find out the metal, which one is the metal, and here we need to find out the coordination number and oxidation state of the metal, okay, respectively. So here M diethylamine, diethylamine, that is En twice, it is a neutral ligand. It is a neutral ligand to find out the oxidation state. So here oxalate ion is there. It is a negative ligand. It is a bidentate ligand, and diethylamine is also bidentate ligand. So it is a negative ligand. The anionic ligand, it is an anionic ligand. NO2 is also an anionic ligand. Where, let's see. So here the general oxidation state for ethylene diamine is 0. It is mainly 2. For oxalato it is 0. So oxidation of M will be X plus 0. 2 oxalato is there. 2. See, it is a bidentate ligand, right? Oxalato, it is a bidentate ligand. 2 is there. So that means here 2 into 2 minus bidentate ligand. That is why I have taken here 2. So 2 donor atom, that is 2 into charge on oxalato is minus 2. Minus 2 is equal to 0. Is equal to 0. That is whole charge is minus 1. That is whole charge is minus 1. Here minus 4. Minus 4 will take that into the right hand side. Minus 1 plus 4, it is plus 3. The oxidation state of metal is plus 3. You can see here second B is ruled out, C is ruled out. Then what is the answer for this, students? What is the answer? What is the answer, Jivita? A, you are telling that is 6 and 3. Saujanya, you are telling 6 and 3. Let's see this. So we have confirmed that is oxidation state is 3. So that means 4. You will go to the B and C is ruled out. Left out is A and D. In that coordination number is 6. Of course, bidentate ligand, that is 2 ligands are there. Bidentate ligand is there. 2 number is there. And here this is also bidentate ligand. Then total 6 is there. So coordination number is 6. So answer is A. Very good. You can see here. So it is a diethylamine. Diethylamine. So, and this is an oxalate ion, that is oxalate ligand. When you see what structure is this? Structure is this. Actually, this is M. Actually, this is M. So coordination 1, 2, 3, 4, 5, 6. Total coordination number is 6. Oxidation state just now we have calculated, so that it is 6. 6 and 3. The number of isomers possible for octahedral complex. So you know that octahedral complex, when the different, it depends on the, again it depends on the ligands. Here cobalt is a metal, that is 2 same ligands. One, that is Ma2 C, then B2. Okay, A2 B2 and C2 is there. Then Ma2 B2 and C2. Then what is the possible isomers? Let's see the possible isomers. In octahedral complex, for this complex there are 2 geometrical isomers. One is cis isomer, other one is trans isomer. Cis isomer has 2 optical isomers, that is D cis and L cis isomer. Here the answer is that is D. 4 isomers are present. You can see here trans isomers, See, trans isomers, they have written NH3Cl, NH, that is diethylamine. This is diethylamine bidentate ligand to donor atom. And here NH3Cl trans isomer, and this is also a trans isomer. You can see here. And see, one of the trans isomer, see, one of the isomer is there. Here, optical isomers, there mirror images non-superimposable, mirror images and non-superimposable. Cis isomer shows optical isomerism due to the absence of plane of symmetry. If there is no plane, the plane of symmetry is absent in this case. So that is why totally 4 isomers are present. So CO is a strong ligand than Cl minus because of what? It is a neutral molecule. What is the answer for the students? Very simple it is. What is the answer, Saujanya? Okay, Saujanya, she is telling B, option B, and Shravani option B. Let's check. So here, because it is having pi bonding, that is pi bonds it is having, and it is also involved in the back bonding. That is why CO is the, see, that is lower HOMO energy means that CO is a poorer sigma donor orbital towards the metal than Cl minus. Likewise, lower LUMO makes it better pi acceptor. These two reasons conflicting the strong pi acceptor are strong field ligands. So before poorer sigma donors are weaker in weaker field ligands. So that CO is the answer is D. The bivalent metal ion having maximum paramagnetic behavior among the first transition series element. What is the answer for the students? What is the answer for the students? Hello? What is the answer for this? The bivalent metal ion having maximum paramagnetic behavior among the first transition series. Which one is having? Yes. Saujanya, you're telling yay. Okay, let's see that. Yes, of course. Let's see the answer for this. So Mn2 plus means, for everything I have given here, number of unpaired electrons also I have mentioned here. That is Mn2 plus means argon 3d5, 4s0, that is not 5, that is, sorry, 4s0. 3d5 means half filled, that is unpaired electron. Total number of unpaired electron is 5 in Mn2 plus. In Cu2 plus is number of unpaired electron is 1. Scandium also unpaired electron is 1. In copper also unpaired electron is 1. So here Mn2 plus is 5, it containing 5 unpaired electron, hence it is having maximum paramagnetic behavior. Okay, answer is A. Very good. So in which when a brown compound Mn is treated with HCl gives B, the gas taken in excess reacts with the ammonia, it gives an explosive compound. The compound A and B and C are. I'll show the reaction directly. I'll go to the reaction. MnO2 is treated with HCl. You will get MnCl2, that is manganese dichloride. You will get manganese dichloride along with the liberation of chlorine gas. Then the chlorine gas is treated with the ammonia. You will get trichloroamine. Trichloroamine. It is an explosive liquid. It is an explosive liquid. Then what is the answer for the students? What is the answer for this question? What is the answer for this question? Hello. Saujanya, what is the answer for this question? Jivita, are you there? Saujanya, you are telling A and C. Confusion? Okay, Shravani C. Okay, answer is, let's see the answer. Answer is A. MnO2, Cl2 and NCl3. All are present. A, B, C. This is MnO2 is A, then chlorine gas is B, then C is NCl3. So what is the answer, students? Answer is no, ma'am, C. You are telling C. Let me check once. Mn3O3, Cl2, NCl3. Okay, this. Okay, we'll go to the next question. Which of the following sequence is correct regarding field strength of ligand as per spectrochemical series? You know, spectrochemical series, the first is CO, then Cn. I told you carbon first, then nitrogen, then followed by oxygen, followed by halides. Here you just check So here, which one is the increasing order? We'll go from here to here. It is increasing order. What is the answer for this, students? What is the answer for this? What is the answer for this? Option B you're telling. Let's see the answer. Why answer, Saujanya, answer option B is correct? Option B is correct. SCN is there. You know, yes, of course, your answer is correct there in all the cases. So in first is actually SCN minus is a strong ligand compared to fluorine. So this is wrong. That is why first option is ruled out. The third option you can see this is also this is second strong ligand. Okay, and compared to SCN, CO is very strong. This is also ruled out, and this is also ruled out. Option B is correct. You are right, Saujanya. So that is answer is A. Good. Okay, what is the IUPAC name of this compound? What is the IUPAC name of this compound? Fast. What is the answer for this? Shivani, you're telling A. Let's see this. This oxidation state, we have calculated oxidation state. That is oxidation state is +3. Oxidation state is +3. In all the cases, oxidation state is +3 only. First, we need to write cationic part, then followed by anionic part. Then, so here, chloro bis diethylene amine, chloro bis diethylene amine, nitrito O cobalt 3 chloride. Cobalt 3 chloride is the, so answer is A. Good. So which of the following will be able to show geometrical isomerism? So which one is exhibiting geometrical isomerism? Students? Yes? Square planar will exhibit geometrical isomerism, tetrahedral, square planar, and then tetrahedral. Here only two hybridization they are given, square planar and tetrahedral, but the ligands are different. Ligands are different. So what is the answer for the students? What is the answer? Shravani, Priya, what is the answer? Veena, Saujanya. Okay, Veena, she's telling answer is 3. Let's check what is the answer for this. So as it is known fact that tetrahedral arrangement does not show geometrical isomerism because symmetry based on the symmetry. Geometrical isomerism, while square planar shows the geometrical isomerism. Then option B and option C are option B and option D are ruled out. Then left out is option B and option A. Okay. So here, therefore, only, but the condition is that all the groups must be different. So in that case, only it will exhibit. There are two isomers. So in MA3B, all the arrangements will be the same. Hence, it will not show geometrical isomerism. Therefore, only MABCD will show geometrical isomerism. That is cis and trans isomers. Cis and trans isomerism it will shows. So hence, answer is C, square planar MABCD. The electronic configuration of gadolinium is, what is the electronic configuration of gadolinium? So here, gadolinium 2 plus it is, that is 4f7 5d1. Answer is D. Okay, students, so I'm going to end this topic here. Only 2 questions are there. Okay, right. Sorry. Just 3-4 questions are there. Just I'll finish it off. So on heating potassium permanganate, so at 513 Kelvin, you will get oxygen gas is liberated. Answer is, that is, here slight mistake has happened. That is MNO. It is MNO. Actually, it is MNO. Answer is MNO. The complex ion having minimum magnitude of, that is CFSC. CFSC, you can see here CFSC low. That is here CN6 is there, CN minus is there. So strong ligand. So strong ligand, CFSC is more. So answer A is ruled out. So you just come to these three. So ammonia, chlorine and water. Chlorine is a neutral ligand. This is also exhibiting low CFSC, and Cl6 also, chlorine also exhibiting low CFSC. Ammonia, when it is present in ammonia, cobalt in 3 plus, ammonia ligand is present. It is in high spin complex. It is an it is a low spin complex. Pairing will occurs. So when it is in low spin complex, CFSC will be the more. Then you just come to these two. Just come to these two. You can see here. They have written here. CFSC, that is Cn minus strong ligand, then ammonia followed by water followed by chlorine. So according to the field strength, chlorine exhibiting a weak strength, so splitting will be less. So answer is C. So they have calculated here minus 0.4 del for the then for these two it is 1.2 del naught. This is minus 2.4 del naught. The least is for the chlorine. Okay. So the coordination number of iron and cobalt in the complex here, that is answer is 6 and 4. You can see the answer here. Okay. Number of isomerism exhibited by the compound. It is bidentate ligand. You can see here cis and trans. That is 1, 2, and 3. That is answer is B. Okay, students. So yeah, same. This is same. It is repeating. Okay, right. Okay. All of you got? All of you got? Hello, students. Saujanya, Veena, understood? Understood? I think I'm going to wind up the class. If you have all the best on from Monday onwards, you are going to you're going to attend mock classes, right? Okay. Thank you very much, and all the best. Do well. So thank you, students. Thank you. For your for your mark as well as for your CET. So all the best. Do well. Thank you.
Good afternoon, dear students. Yeah, I am Dr. Raghavendra UP. Yesterday, we had a discussion on brief discussion on thermodynamics. Let me explain a few more concepts, and we'll start solving problems on it. Just a moment. Yeah. Well, you are familiar with this equation. PV is equal to NR into T, where the symbols have their usual meanings. P for pressure, V for volume, N is number of moles, R is gas constant, and T is temperature. Okay. Based on this, you can individually state or explain Boyle's law, Charles' law, and Gay-Lussac's law, and this is called an ideal gas equation, right? Then for isothermal process, PV is equal to a constant, temperature is constant. An adiabatic process is represented by the equation PV to the power gamma is equal to a constant. It's a rapid process. Okay. Then in case of isobaric process, pressure remains constant. Isochoric process, volume remains constant. Then apart from this, you need to know about Carnot engine. Efficiency of a Carnot engine is given by eta is equal to T1 minus T2 divided by T1, because in case of a Carnot engine, there will be a source at high temperature and a sink, another reservoir at lower temperature T2, and there will be a working substance. From the source, Q1 amount of heat is supplied to the working substance, and Q2 amount of heat is rejected to the sink. Therefore, work done or heat energy used for work done is given by Q1 minus Q2. Q1 minus Q2 amount of work will be done, okay, by the working substance. And eta is equal to T1 minus T2 divided by T1, and eta is also expressed in terms of Q, heat supplied. So heat supplied is Q1, heat rejected is Q2. Eta is equal to work done divided by heat supplied. W is equal to Q1 difference Q2. That divided by Q1 will give you efficiency of a Carnot engine. Okay. Then when it comes to number of degrees of freedom, it is expressed in terms of 3n minus k is equal to F. Here n is atomicity, number of atoms in a molecule, and k represents number of independent relations. For example, there is a diatomic gas molecule, there are 2 atoms and there is one independent relation connecting them. Therefore, number of degrees of freedom is given by 3 into atomicity is 2 minus number of independent parameters connecting the atoms is 1. So it is 6 minus 1 is equal to 5. So there are 5 degrees of freedom. Then in case of triatomic gas molecule, so supposing the molecule is of this shape, okay, there are 3 atoms and there are 1, 2, 3 independent relations. Therefore, number of degrees of freedom is given by 3 into number of atoms is 3 minus number of independent relations is 3. 9 minus 3 is equal to 6. So it has got 6 degrees of freedom. Okay. Then the law of equipartition of energy. Average kinetic energy is given by per mole is given by 3 by 2 RT. And average kinetic energy per molecule is given by E is equal to 3 by 2 into KB into T. Of course, you can bring in the concept of number of moles here, okay, or number of degrees of freedom, and this can be related to specific heat. CV is equal to 3 divided by 2 into R in case of molecules. Of course, if you multiply this by number of degrees of freedom, this will vary depending on atomicity. Okay. So these are the basics we need. Now we'll start solving problems. First one, which of the following is not a state function? We need to identify the quantity which is not a state function. State function is one which explains the state of a system. Temperature is a measure of degree of hotness or coldness. So it represents the state. Then entropy, degree of disorderness, it represents state. Pressure is force divided by area, right? Whenever force is applied or pressure is exerted on a system, there will be changes in the alignment, molecular movement, or they get compressed or elongated. These things happen. It also represents the state of a system. Work done does not represent the state of a system, so it is not a state function. Therefore, correct option is D. D is correct option. Okay. Now we'll move to the next one. If gas is heated at constant pressure, then what percentage of total heat supplied is used up for external work? We have to find the percentage of heat supplied that is used for external work. That means we have to find out delta W divided by delta Q. What is delta W? Delta W is equal to P into dV, right? But this can be written as, what is PV? PV is equal to nRT, right? What is P into dV? nR into dt or delta T, right? You can write either dW or delta W. dW is equal to P into dV, right? that is equal to N into R into dt, right? So dW is equal to N into R into dt. This is from ideal gas equation. And dq or delta q is equal to N into Cp into dt or delta T. Okay, this is the equation which connects the amount of heat and specificated constant pressure. Okay, now in the problem it is given that pressure is kept constant, therefore dq is equal to N into Cp into dt. Now let us find the ratio dw divided by dq or delta w divided by delta q is equal to numerator there is nr dt, denominator N into Cp into dt. N and dt get cancelled, therefore we have r divided by Cp. dw divided by dq is equal to r divided by Cp. From Mayer's equation we know what is r equal to. We have Cp minus Cv is equal to r, right? So Cp minus Cv divided by Cp is equal to dw divided by dq, or dw divided by dq is equal to 1 minus Cv divided by Cp, right? But we know that gamma is equal to Cp divided by Cv, ratio of specific heat capacities. Therefore, dw divided by dq is equal to 1 minus we have Cv divided by Cp, but we know that Cp divided by Cv is gamma. Therefore, Cv divided by Cp must be equal to 1 by gamma, right? So this is gamma minus 1 divided by gamma. Gamma is given 4 by 3 minus 1 divided by 4 by 3. 4 by 3 minus 1 divided by 4 by 3 gives us how much? Any guesses? 1 by 4. This into 100% is 0.25 into 100%, that is equal to 25%. Therefore, the correct option is 25%. Okay, therefore, the percentage of heat supplied is 25%. Next one. A gas under constant pressure of 4.5 into 10 power 5 Pascal when subjected to 800 kilojoules of heat. What is given here? Delta Q is known to you. 800 kilojoules, right? 800 kilojoules. Changes the volume from 0.5 meter cube to 2 meter cube. Change in volume is given. The change in internal energy of the gases, you have to find the change in internal energy. From first law of thermodynamics, we have Q is equal to du plus dw or delta U plus delta W. Here delta U is change in internal energy, right? So delta U is equal to delta Q minus delta W. Delta Q minus delta W. Delta Q is given in the problem. Delta W we have to find out. Okay. How do you find out delta W? Delta W is equal to P into delta V, because we have W is equal to P into V. Pressure into volume gives us work done. So delta W is equal to P into delta V, right? This is written as delta W is equal to P is given constant pressure. It is 4.5 into 10 to the power 5. Change in volume is 2 meter cube minus 0.5 meter cube. That is 1.5 meter cube, right? Change in volume is known to you. Now this gives delta W. Delta W is found to be equal to, you find the product product turns out to be 6.75 into 10 to the power 5 joules. Okay, so dW or delta W is known to you. Delta Q is 800 into 10 to the power 3 or 8 into 10 to the power 5. 8 into 10 to the power 5. Now coming back to the expression for change in internal energy, we can write delta U is equal to 8 into 10 to the power 5 minus 6.75 into 10 to the power 5. To take 10 to the power 5 common, and 8 minus 6.75 is 1.25. So 1.25 into 10 to the power 5 joules. So change in internal energy of the gas is found to be equal to 1.25 into 10 to the power 5 joules. Move to the next one. Yeah, read out the problem. Heat is supplied to a diatomic gas at constant pressure. The ratio of delta Q, delta U, and delta W is to be calculated. It's a diatomic gas, and pressure is kept constant. Okay, for a diatomic gas, there are 5 degrees of freedom. Since there are 5 degrees of freedom, CV is equal to 5 by 2 times R. 5 by 2 times R. And CP is equal to 7 by 2 R. This is because we have CP minus CV is equal to R. CP is equal to CV plus R. Right. Therefore, we get CP is equal to 7 by 2 R. And at constant pressure, delta Q is equal to N into Cp into delta T, where Cp is specific heat at constant pressure. Okay. Now delta Q is equal to N into Cp is 7 by 2 R into delta T. So delta Q is known to you. Now we'll find out delta U, change in internal energy, which occurs at constant volume. So the equation for it is N into Cv into dt, right? Now let us substitute for Cv here. Delta U is equal to N into Cv is how much? 5 by 2 into R into dt, right? So delta Q is known to you, delta U is known to you. We need to find out delta W also. We'll make use of first law of thermodynamics, according to which delta Q is equal to delta U plus delta W, or delta W is equal to delta Q minus delta U, right? How much is that? You take NR by 2 into delta T or dt common. What do you get? You take the difference, 7 by 2 NR delta T minus 5 by 2 NR delta T. This is equal to how much? NR delta T by 2 common, 7 minus 5, 2 and 2 get cancelled. We get NR delta T for delta W. Okay. Now, what is the ratio in all the three? NR into delta T is common. Therefore, we can write the ratio as delta Q is to delta U is to delta W is equal to delta Q, it is 7 by 2. Okay, 7 by 2. Then the delta U is 5 by 2, and delta W is 1, because the coefficient of NR delta T is 1. Now multiply by 2, you get 7 is to 5 is to 2. Therefore, delta Q, delta U, delta W heat supplied, change in internal energy and work done are in the ratio 7:5:2. So option B is correct. Option B. We'll move to the next one. Yeah. If the amount of heat given to a system is 35 joules, amount of heat given to a system is 35 joules. Delta Q is equal to 35 joules. And the amount of work done on the system is 15 joules. Delta W is equal to minus 15. Work done by the system is positive, work done on the system is negative, minus 15 joules. Then the change in internal energy of the system is, we have this equation, delta Q is equal to delta U plus delta W. Delta U is equal to delta Q minus delta W. It is 35 minus of minus 15. That is equal to 50 joules. Okay. Therefore, option D is correct. Change in internal energy of the system is 50 joules. Yeah. We'll move to the next one. In a cyclic process, work done by the system is 0 more than heat given, equal to heat given to the system, independent of heat given to the system. In a cyclic process, the system returns to the original state. Since the system returns to the original state, the change in internal energy must be equal to 0. Delta U is equal to 0. Now we'll write the equation. Delta Q is equal to delta U plus delta W from first law of thermodynamics. But delta U is 0. Therefore, delta Q is equal to delta W. Which option is correct? Work done by the system is equal to heat given to the system. Option C is correct. We'll move to the next one. Pressure P, volume V, and temperature of a certain material are related by the equation P is equal to alpha T squared divided by V, where alpha is a constant. Work done by the material when temperature changes from T0 to 2T0, pressure remaining constant. We have to find the work done by the material during the change in temperature from T0 to 2T0. Okay. Work done is given by P into dV, right? dV is what we have to find out, and we need to integrate it. Okay. How do you find out dV? Let us make use of the given equation. See, this is the equation, cross multiply. V is equal to alpha T squared divided by P. It is given that pressure is a constant. Therefore, let us differentiate volume V with respect to temperature T. So we get dV divided by dt is equal to 2 alpha into T divided by P. So dV divided by dt is known to you. This implies dV is equal to 2 alpha T divided by P into dt. Okay, this is the change in volume. Now, if you want to find the work done, total work done during the change in temperature from T0 to 2T0, you have to integrate this particular equation. Okay, this equation. W is equal to P into, what is dV? 2 alpha T divided by P into dt with limits T naught to 2T naught, T naught to 2T naught. Now what happens? P and P get cancelled. Alpha is a constant, 2 alpha is a constant. So write 2 alpha outside, and integration of T is T squared divided by 2. Okay, limits T naught to 2T naught. Right. Now 2 and 2 get cancelled. Therefore, W is equal to alpha into T squared is written as 2 T naught squared. Okay, 2 T naught squared minus lower limit is T naught squared. So work done is equal to alpha times 4 T naught squared minus T naught squared is equal to 3 T naught squared, 3 T naught squared into alpha. So correct option is 3 alpha T naught squared. Option A is correct. Option A. So 7th one, option A. We'll move to the next one. Yeah. 1 mole of an ideal gas expands adiabatically at constant pressure. It's an adiabatic process. Pressure is being kept constant such that its temperature T is proportional to 1 by root V. That is, T is proportional to V to the power minus half, V to the power minus half. We have to find the value of gamma for the gas. Since it is an adiabatic expansion, we have PV to the power gamma is equal to a constant. PV to the power gamma is equal to constant. Okay. But here pressure is a constant, right? We'll express the equation in terms of temperature and volume. What is P equal to? P is equal to RT divided by V. Let us substitute for P as RT divided by V into V to the power gamma is equal to constant K. Here R is a constant and V goes to numerator. It becomes V to the power minus 1. So it is TV TV to the power gamma minus 1 is equal to constant. Or we can write T proportional to V to the power 1 minus gamma, because we can write this as T is equal to K divided by V to the power gamma minus 1 in the denominator. That becomes V to the power 1 minus gamma on coming to the numerator. Right. We already have an equation connecting temperature and volume. The first equation, that is T is proportional to V to the power minus half. And now we have got T proportional to V to the power 1 minus gamma. Let us equate. By equating, we get 1 minus gamma is equal to minus half, or gamma is equal to 1 plus half. That is equal to 1.5. So gamma is equal to 1.5. Option B is correct. So 8th one, option B. We'll move to the next one. A 400 cc volume of a gas having gamma is equal to 5 by 2. Gamma is equal to 5 by 2 is suddenly compressed to 100 cc. It is an adiabatic compression, sudden compression to 100 cc. Okay, initial volume is given, right? V1 is equal to how much? 400 cc, and the new volume is given, it is 100 cc. If the initial pressure is P, we will call initial pressure as P1. P1 is equal to P. What is the final pressure? P2 we have to find out in terms of P. Since it is an adiabatic process, we have PV to the power gamma is equal to a constant. Okay, or P1 V1 to the power gamma is equal to P2 V2 to the power gamma. Now let us express the formula in terms of P2. Since we are supposed to find out the new pressure P2, so P2 is equal to P1 V1 to the power gamma divided by V2 to the power gamma, that is P1 times V1 divided by V2 to the power gamma. Or P2 is equal to, initial pressure is P itself. We'll substitute for V1 and V2. Initial volume is 400, V2 is 100. 400 by 100, it is 4, right? 4 to the power. Gamma is pi divided by 2. So it is P times, we can write 2 squared whole to the power pi by 2. 2 and 2 get cancelled. So we will left with 2 to the power 5. 2 to the power 5 is 32. So it is 32 times P. So P2 is equal to 32 times P. Correct option is C. Ninth one, option C is correct. Yeah. We'll move to the next one. A polyatomic gas whose gamma is given, it is 4/3, is compressed to 1/8 of its initial volume adiabatically. So new volume is 1/8 times the initial volume. If its initial pressure is P0, what is the new pressure? So this is also an example for adiabatic compression. For an adiabatic process, as you all know, PV to the power gamma is equal to a constant. Okay. Well, we'll take the pressure as P, new pressure, and the new volume is initial volume divided by 8 to the power 4/3. That is equal to initial pressure is P0 and initial volume is V0 to the power 4/3. It's like earlier equation. Earlier I wrote P1 V1 to the power gamma is equal to P2 V2 to the power gamma is equal to constant. Here P2 is P, V2 is V0 by 8, P1 is P0, V1 is V0, because initial volume is expressed, initial pressure is expressed in terms of P0. I have written P0 and volume as V0. So all we have to find out is P here. Okay. Now what is P equal to? P is equal to what happens? V0 to the power 4/3, V0 to the power 4/3 get cancelled. 8 to the power 4/3 goes that side. So P0 into what else? 8 to the power 4/3. So that is P0 into 16P. We'll verify. P0 into 8 is written as 2Q to the power 4/3. 3 and 3 get cancelled. 2 to the power 4, right? It is 16. 16 into P0, 16 P0. Yeah, it's correct. How much? Option 16 P0, option B. So 10th one, option B is correct. We'll move to the next one. The temperatures T1 and T2 of heat reservoirs in the ideal Carnot engine are 1500 degrees Celsius and 500 degrees Celsius respectively. Temperature of the source and the sink are given. If T1 increases by 100 degrees Celsius, what will be the efficiency of the engine? You have to find the efficiency of the engine. Temperature of the source is T1 is equal to, how much is given? 1500 degrees Celsius, but you have to express it in Kelvin. And if it increases by another 100 degrees Celsius, what is the new temperature of the source? 1500 plus 100, that is 1600 plus 273 in terms of Kelvin. That is the temperature of the source, right? How much is it? 1873 kelvins. This is the temperature of the source. And as far as sink is concerned, temperature is T2. T2 is how much? 500 degrees Celsius. 500. We'll write it in Kelvin. 500 plus 273 is equal to 773 Kelvin. Somebody, Manu has given C as the correct option. We'll verify. 773 Kelvin. Now efficiency is given by work done divided by heat supplied. Okay, that is equal to T1 minus T2 divided by T1 or 1 minus T2 divided by T1. Okay, it is 1 minus T2 is how much? 773. T1 is 1873. That is equal to how much? 1873 minus 773 is 1100 divided by 1873, and you multiply this by 100%. Okay. In the problems of this kind, we have to go for an approximation method. This is written as 11 by 18 into 100%. Okay. You find out the approximate answer. So, the correct option is 59%. Option, yeah, option B. Of course, problems of this type take slightly longer, but some questions, higher level questions are included here. Okay, you should be able to get some idea from them. Some of them may not appear in CET, but you should get some ideas. The approach must be understood properly. Okay, that's why some higher level questions are also included. Okay, only to help you get better idea. But this is of course a very simple problem. 11th one, option B is correct. Go to the next one. Yeah. A Carnot engine operates with a source at 500 kelvins and a sink at 375 kelvins. Temperature of the source is 500 kelvins and that of the sink is 375 kelvins. Engine consumes 600 kilocalories of heat per cycle. Heat given to the engine is so much, 600 kilocalories. Okay. The heat rejected to the sink per cycle. Heat given is Q1, right? Heat rejected is Q2. Like this is the working substance. Here is source. Heat given off to the working substance is Q1. Here is sink. Heat rejected is Q2. Okay. Now we have to find the heat rejected to the sink per cycle. That means we have to find the value of Q2. First, let us find the efficiency of the engine. Somebody has given A as correct option. We'll verify. Efficiency of the engine is 1 minus T2 divided by T1. 1 minus T2 divided by T1. That is equal to 1 minus 375 divided by 500. How much is that? 500 minus 375, 125. 125 divided by 500. You simplify this, you get 0.25, which is equal to 25%. So efficiency of the engine is known to you. Now we have to find out heat rejected to the sink per cycle. That is Q2. You have to find a value of Q2. Okay. efficiency is given by 1 minus Q2 divided by Q1. This is because Q1 by Q2 is proportional to T1 divided by T2. Higher the energy supplied to the system, higher the temperature, larger the energy supplied, greater the temperature. So Q1 by Q2 is proportional to T1 by, divided by T2. So this way T2 divided by T1 is now written as Q2 divided by Q1. Okay. Now let us substitute for the known quantities. Eta efficiency is 0.25 is equal to 1 minus Q2 divided by Q1 is how much? 600 kilocalories. Okay. Let us write down 600 directly. Don't convert that into calories, multiplying by 10 power 3 because the final answer is also given in kilocalories. Okay, so 0.25 is equal to 1 minus Q2 divided by 600, or Q2 divided by 600 is equal to 1 minus 0.25, that is equal to 0.75, or Q2 is equal to 0.75 into 600, that is 75% of 600, which is 450. Q2 is equal to 450 kilocalories. So option C is correct. Question number 12, option C is correct. We'll move to the next one. Question number 13. An ideal gas heat engine operates in a Carnot cycle between 227 degrees Celsius and 127 degrees Celsius. So temperature of source and sink are given. Temperature of the source is 227 plus 273. We are expressing it in Kelvin, is equal to 500 kelvins. For sink, the temperature is T2. It is 127 plus 273 is how much? 400 kelvins. It absorbs 6 kilocalories of heat at higher temperature. Heat absorbed is Q1. How much is that? 6 kilocalories. We have to find the amount of heat rejected to the sink in kilocalories. We have to find out Q2. Like I explained before, Q2 divided by Q1 is equal to T2 divided by T1. Okay. Cross multiplying, you get Q1 times T2 divided by T1. Now let us substitute for the quantities. 6 into T2 is 400 divided by T1 is 500. Now it is 24 divided by 5. 24 divided by 5. How much? 4.8. Option A is correct. 4.8 kilocalories. So 13th one, option A. We'll move to the next one. The efficiency of a Carnot engine is 50% and temperature of sink is 500 kelvins. If temperature of the source is kept constant and its efficiency is raised to 60%, then required temperature of sink will be, without changing the temperature of source, we increase the efficiency. Then what is the temperature of sink required? First, let us find the temperature of source from the given data. Initial efficiency is eta 1. Eta 1 is equal to 0.5, right? Temperature of sink is T2. T2 is equal to 500 kelvins. Temperature of source is not known to us. Let us first find it out. Eta 1 is equal to 1 minus T2 divided by T1, right? It is 0.5 is equal to 1 minus T2, that is 500 divided by T1. Now you simplify this, you get the value of T1. How much is T1 here? 500 divided by T1 is equal to 1 minus 0.5, that is 0.5 itself. So T1 is equal to 500 divided by 0.5, that is 500 divided by half. So it is 1000 kelvins. Temperature of the source is known to you. Now we have to increase the efficiency to 60% without changing the temperature of source. Temperature of sink must be calculated. Now the new expression is written as eta2 is equal to 1 minus T2 dash minus T1 itself. Here we are not changing the temperature of source. So it is written as T1 itself, but sink's temperature is being changed. We call it T2 dash. Eta2 is given, it is 60%. 0.6 is equal to 1 minus T2 dash divided by T1 is 1000. Right. Now we'll find out T2 dash. T2 dash divided by 1000 is equal to 1 minus 0.6 is equal to 0.4. Right. So T2 dash is equal to 0.4 into 1000 is equal to 400 kelvins. Right. So required temperature of sink for the efficiency to be 60% is 400 kelvins. 14th one, option C. We'll move to the next one. Yeah. If the input to a Carnot engine is thrice the work it performs, then the fraction of energy rejected to the sink. What is given? Input to a Carnot engine is thrice the work it performs. Input given, amount of heat supplied to the working substance is nothing but Q1. Q1 is equal to 3 times the work it performs. Heat supplied is Q1, heat rejected to the sink is Q2, work done is Q1 minus Q2, right? So heat given is Q1 is equal to 3 times Q1 minus Q2. What is that we have to find out? Fraction of energy rejected to the sink. While finding the fraction, we must divide the amount rejected by amount supplied. This will give you the fraction of heat rejected. Okay. Now this is Q1 is equal to 3 Q1 minus 3 Q2, right? Or 3 Q2 is equal to 3 Q1 minus Q1 is equal to 2 Q1. Okay. So Q2 divided by Q1 is equal to 2 by 3. Q2 divided by Q1 is equal to 2 by 3. So option C is correct. Fraction of energy rejected to the sink is Q2 divided by Q1 is equal to 2 by 3. Yeah. We'll move to the next one. A cylinder contains 12 liters of oxygen at 20 degrees Celsius and 15 atmospheric pressure. Volume is given, initial temperature is given, initial pressure is given. The temperature of gas is raised to 35 degrees Celsius. Volume is increased to 17 liters. What is the final pressure? New temperature is given, new volume is given. We need to find the new pressure. For this, let us use ideal gas equation according to which PV is equal to nRT, or PV divided by T is equal to a constant generally, or P1 V1 by T1 is equal to P2 V2 divided by T2 is equal to P3 V3 divided by T3 is equal to constant. This continues, right? In this problem, we have to find out new pressure, that is P2. Cross multiplying, we get P2 is equal to P1 V1 into T2 divided by T1 into V2. Am I correct? T2 T1 V2 is equal to P1 V1 T2. Now that you know the values of P1 V1 T2 T1 and V2. What is the initial pressure? 15 atmospheres. Okay, 15. Initial volume is 12 liters. Here you don't have to convert this into meter cube because you are taking the ratio, units get cancelled. There is no necessity of converting the units from one system to another. Okay. Then temperature needs to be changed. It must be expressed in Kelvin. This is very important here. A new temperature is how much? 35 degrees Celsius. You convert that into Kelvin. 35 plus 273 is how much? 308 divided by T1. Initial temperature is 20. 273 plus 20 is 293, and the volume, new volume is 17 liters. Okay. You find the approximate value. You can retain 15 and 12, and 17 can be reduced to 15, 300 to 308 to 300, 293 to 290. Okay, to work it out, you'll get 11 atmospheres approximately. So P2 is found to be equal to 11. See here, while solving this problem or calculating the final answer, like I told before, you round off the numbers to the nearest one which are easily divisible. Okay, like 308 may be written as 310 or 300. If you decrease this by a certain extent, decrease the denominator almost by the same amount. Okay, that will compensate for retainment of ratio. Okay, so this way you get nearly 11 atmospheres. So option B. We'll move to the next one. The temperature of the gas contained in a closed vessel increases by 1 degree Celsius. Okay, temperature increases by 1 degree Celsius. Change in temperature is given 1 degree Celsius or 1 Kelvin, which is equal to 1 Kelvin itself. When pressure of the gas is increased by 1%, pressure is increased by 1%, leading to increase in temperature by 1 degree Celsius. The initial temperature of gas, you have to find the initial temperature. Here it is given that the temperature of the gas contained in a closed vessel increases. Since it is a closed vessel, volume remains constant. Since volume remains constant, we can write P2 divided by P1 is equal to T2 divided by T1. Because from ideal gas equation, we have learned that PV is equal to nRT. When V is a constant, P and T are directly proportional. That means P by T is a constant. Or P1 by T1 is equal to P2 divided by T2, right? Or when temperature is constant, PV is equal to constant, or P is equal to 1 by P is proportional to 1 by V, right? Or P1 V1 is equal to P2 V2, that way. So here P2 divided by P1 is equal to T2 divided by T1. Pressure is increased by 1%. So P2 is written as initial pressure is P1 and it is increased by 1%. So it is 0.0 P1 divided by P1 itself. So what is the new pressure? It is increased by 1%. So initially it is P1 plus 1%. That is the new pressure P2. That is equal to temperature. New temperature increases by 1 degree Celsius, which is equal to 1 Kelvin itself. So numerator will write T1 plus 1. When I write 1 here, it is in Kelvin, not degree Celsius, because capital T is absolute temperature divided by T1. Okay. Now numerator you can take P1 common. So P1 in the numerator, that is taken common, and T1 in the denominator get cancelled. Therefore, you are left with 1 plus 0.01 in the on the left hand side. Is it clear? You take P1 common in the numerator of left hand side. That T1 and denominator P1 get cancelled. You'll be left with 1 plus 0.01. That is equal to, over here, what do you get? T1 plus 1 by T1 is T1 by T1 plus 1 by T1. That is 1 plus 1 divided by T1. Right. Now plus these two get cancelled. When you shift 1 to the other side, becomes minus 1. They get cancelled. So 1 by T1 is equal to 0.01. T1 is reciprocal of this. 1 divided by 0.01. Okay. 0.01 is 10 power minus 2, which on coming to numerator will become 100. So T1 is equal to 100 kelvins. Initial temperature is 100 kelvins. 17th one, option T is correct. We'll move to the next one. A balloon contains 1500 meter cube of helium at 27 degrees Celsius and 4 atmospheric pressure. The volume of helium at minus 3 degrees Celsius temperature and 2 atmospheric pressure will be. It's almost same as one of the earlier problems. Okay. So we have to use the formula P1 V1 by T1 is equal to P2 V2 divided by T2. Right. All we have to find out is volume of helium. So we have to find out V2. Cross multiplying, we get V2 is equal to P1 V1 T2 divided by T1 into P2. T1 into P2. V2 is equal to P1 V1 T2 divided by V2 into T1 into P2. Now substitute for all the quantities. Initial volume V1 is given. It is 1500. Okay. Temperature you have to express in Kelvin. Initial pressure is P1. It is 4 atmosphere. Right. New pressure is P2. It is 2 atmosphere. And initial volume, new temperature. New temperature is minus 3 degrees Celsius. Okay, it is capital T is equal to small t plus 273. That is minus 3 plus 273. It is 270 kelvins. Okay, you substitute for all of them. You'll get the final answer. Any guesses? What could be the value of V2? P1 is 4, V1 is 1500, then T2 is minus 3, which is written as 270 in Kelvin, divided by T1 is 27, which is 300 in Kelvins, and pressure P2 is equal to 2. You simplify this, you get V2 is equal to 2700 meter cube. So this is the new volume. Yeah. A perfect gas at 27 degrees Celsius is heated at constant pressure so as to double its volume. The increase in temperature of the gas will be. In this case, what is kept constant? Pressure. So we can write V1 divided by T1 is equal to V2 divided by T2, because we have PV is equal to N or T. T and V are directly proportional, right? At given, constant pressure. Therefore, V1 by V2 is equal to T1 by T2, or V1 by T1 is equal to V2 divided by T2. What is that we have to find out? Increase in temperature of the gas. First, let us find out 600. Somebody has given 600. We'll verify. Find out new temperature. New temperature T2 is equal to T1 V1 T1 V2 divided by V1. Initial temperature is 27, that is 300 kelvins, into V2 divided by V1. What is given here? Volume is doubled. So V2 divided by V1 is 2V divided by V. That is 2 itself. Okay. So temperature is 600 kelvins. Right? But answer is given in terms of degrees Celsius. You convert this into degrees Celsius. Right? How much is the temperature? 600 kelvins in degrees Celsius. Capital T is equal to small t plus 273, which implies T is equal to capital T minus 273. That is 600 minus 273. You have to observe the units carefully. Yeah, you're right. 327 degree Celsius is correct. 600 minus 273 is 327. So option B is correct. Option B. With this, I'll end the session for the day. Thank you.